Tonight, as you drift into sleep, something remarkable will happen. You will dream, not just once, but multiple times throughout the night. 4, 5, perhaps 6 separate dreams will unfold in your mind. Vivid stories, strange landscapes, impossible events that will feel completely real while you're experiencing them. You might remember some of these dreams when you wake. Most, you'll forget within minutes of opening your eyes, but they'll happen regardless, whether you remember them or not. Right now, you're on the threshold, that familiar borderland between waking and sleeping, where thoughts begin to soften and lose their edges, where the concerns of the day start to fade like voices growing distant. Your body knows this transition well. You've made this journey thousands of times every night of your life since you were born. Your body is already preparing, already beginning the slow descent into sleep. The dreams are waiting for you. They're forming already, somewhere in the depths of your mind, assembling themselves from the fragments of your day, from your memories, from your concerns and hopes and fears. Soon these fragments will combine in ways you can't predict or control, creating narratives that surprise you, worlds that couldn't exist anywhere but in your sleeping mind. Dreams are your brain's nightly theater. The stage is always there, the curtain always rises, but you never know what play will be performed. Sometimes it is drama, sometimes comedy, sometimes something strange in genre, defying that makes no sense but feels profound while you're watching. Your audience and actor simultaneously, observer and participant, watching events unfold while also being part of them. And here is something wonderful. Everyone dreams. Every person you've ever met, every stranger you've passed on the street, every human being alive right now, and every human who has ever lived, all of them dreamers. We all share this experience of nightly transformation, of consciousness shifting into a different mode, of visiting places that exist nowhere, but in our own minds. Tonight, you'll join that vast, invisible community of dreamers. All over the world, people are falling asleep right now, beginning their own journeys into the dream world. You're all separate, yet all connected by this universal human experience. Sleep and dreams are the great equalizers. It doesn't matter who you are, where you're from, what you do. Everyone sleeps. Everyone dreams. So as you lie here, you can feel yourself approaching that threshold. The boundary between waking and sleeping is thin, permeable. You're crossing it already, perhaps without fully realizing it. Thoughts are becoming less linear, more associative. The room around you is fading. Your awareness is turning inward, and waiting for you, just beyond this threshold, are the dreams. They've been waiting all day. And so are you. Dreams have fascinated humans for as long as we've been human. Probably longer, our ancient ancestors, hundreds of thousands of years ago, must have wondered about these strange nightly visions, just as we do. What are these impossible experiences that visit us in sleep? Where do they come from? What do they mean? Ancient Egyptians took dreams so seriously, they created elaborate interpretation guides, dream books listing symbols and their meanings. A dream about crocodiles meant one thing, a dream about bread meant another. They believed dreams were messages from the gods, communications from the divine realm, but required careful decoding. Special priests were trained in dream interpretation, and pharaohs kept dream interpreters among their closest advisors. The ancient Greeks built entire temples dedicated to dreams. These weren't places for ordinary worship, but for dream incubation, a practice where people seeking answers or healing would travel to temples of Asclepius, the god of medicine, sleep there overnight, and hope to receive a healing dream or prophetic vision. The Greeks believed dreams could cure illness, provide guidance, foretell the future. Dreams were taken as seriously as any waking experience. In the ancient Near East, in Mesopotamia, dream interpretation texts date back 5,000 years, some of the oldest written documents we have. Kings recorded their dreams in official records. Dreams were considered politically significant, potentially affecting the fate of nations. A king's dream could change the course of history if interpreted as an omen of war, or peace, prosperity, or disaster. The Bible is filled with dreams. Jacob's dream of a ladder reaching to heaven, Joseph interpreting Pharaoh's dreams of 7 fat cows and 7 lean cows, predicting 7 years of abundance, followed by 7 years of famine. In these ancient stories, dreams weren't random neural noise, but meaningful communications requiring interpretation and response. Indigenous cultures around the world developed their own rich dream traditions. Native American vision quests intentionally sought dreams as sources of guidance and spiritual power. Australian Aboriginal peoples speak of the dream time, a mythological era when ancestral beings dream the world into existence, with dreams continuing to connect present reality to that sacred past. Modern science has revealed the mechanisms behind dreams, the brain regions, the neurotransmitters, the sleep stages. We can watch dreaming brains on fMRI machines, see which areas light up, measure the electrical activity. We know more about the how of dreaming than any previous generation. And yet, the mystery remains. Because knowing that dreams occur during REM sleep, knowing which neurons fire and which chemicals are involved, this doesn't really explain what dreams are. It doesn't tell us why we have these experiences, why they feel meaningful, why they stay with us sometimes, haunting or inspiring us. Science illuminates without explaining away. The mystery deepens even as knowledge grows. Every culture has tried to understand dreams. Every era has developed theories. And the fact that dreams remain partially mysterious despite all this attention, despite all our scientific tools, suggests that maybe mystery is part of their essential nature. Maybe dreams are meant to be wondered about more than understood. Maybe the question is more important than the answer. When you dream, something extraordinary is happening in your brain. People often think of sleep as rest, as shutting down, going offline, turning off consciousness to recharge. And in some ways that is true, but dreaming is different. During dreams, your brain is not resting. It is working hard. In fact, some brain regions are more active during dreams than during waking. When scientists measure brain activity with EEG or fMRI, they see intense neural firing during dream states. Your visual cortex, the part that processes sight, is as active when you're dreaming of a landscape as when you're actually looking at one. Your emotional centers, especially the amygdala, can be even more active during dreams than during waking emotional experiences. This creates a paradox. You're unconscious, unresponsive to the external world, lying still with eyes closed. By every outward measure, you're deeply asleep. Yet your brain is alive with activity, generating complex experiences, sights, sounds, sensations, emotions, narratives. You're seeing things that aren't there, hearing voices that aren't speaking, experiencing events that aren't happening, and it all feels completely real. Your brain is doing something remarkable, creating an entire world from scratch. When you're awake, your brain builds your experience from sensory input, light entering your eyes, sound entering your ears, touch on your skin. Your consciousness is anchored to reality by constant sensory information. But when you dream, there is no sensory input. Your eyes are closed, receiving no light. Your ears hear only silence, or perhaps ambient noise. Your body lies still. Yet you see, you hear, you feel. You experience a rich, detailed, convincing world landscapes, stretching before you, people speaking to you, objects that you can touch and manipulate. Where does this world come from? Entirely from your brain. Every element of a dream, every color, every face, every emotion is generated by neural activity. Your brain is inventing reality, moment by moment, without any external reference. This world building happens automatically. You don't consciously construct dreams any more than you consciously construct waking perception. Dreams just unfold, surprising you with their content. You're a spectator in your own mind, watching as your unconscious generates scenes and narratives and experiences. Sometimes you're an active participant, doing things in the dream, making choices, responding to situations. But even then, you're not controlling the dream. It is controlling you, pulling you along its strange logic. And here is what makes it even more remarkable. While you're dreaming, you don't know it is not real. Dreams have their own internal consistency, their own dream logic. Impossible things happened. You fly. You meet people who are dead. You're in your childhood home, but it is also your current workplace. The critical, rational part of your mind that would say, wait, this doesn't make sense, is offline. You're immersed completely in the dream reality, believing it absolutely, until you wake. Dreams feel real because, to your brain, they are real. This isn't a metaphor or exaggeration. When you dream about seeing a sunset, the same neurons fire in your visual cortex as when you actually see a sunset. When you dream about running, your motor cortex activates as if you're actually running. though thankfully your body is paralyzed, or you'd be running in bed. When you dream about fear, your amygdala responds exactly as it would to a real threat. Your brain doesn't distinguish between sensory information from the external world and sensory information it generates internally. A neuron in your visual cortex doesn't know whether it is firing because photons hit your retina or because other neurons told it to fire as part of a dream. It just fires. And when it fires, you experience vision, whether the source is external reality or internal simulation. This is why dreams can be so emotionally powerful. When you wake from a nightmare, your heart is actually pounding. Your body has released stress hormones, cortisol, adrenaline. You're sweating, breathing hard, perhaps trembling. Your body responded to the dream threat as if it were real because, neurologically, it was real. The threat existed in your brain, and your brain controls your body. The fact that the threat had no external existence doesn't matter to your physiology. The same applies to positive dreams. Wake from a dream of joy or love, and you might feel genuinely happy, carrying that warmth into waking life. Your brain released dopamine, oxytocin, endorphins during the dream. These chemicals affect your mood, your body, your state of mind. The dream emotion was chemically real, even if the event that triggered it was imaginary. This creates strange moments when you first wake. For a few seconds, or sometimes minutes, you're not entirely sure what is real. Was that conversation with your deceased grandmother real? Did that conflict with your partner actually happen? Or was it a dream? The confusion isn't surprising. Your brain experienced both real memories and dream memories using the same neural machinery. They're stored the same way, feel the same way, carry the same emotional weight initially. Usually, as you become fully awake, you can sort dream from reality. Context clues help. You're in your bed, it is morning. Certain things in the dream were impossible, but sometimes dream memories persist with a vividness that rivals real memories. Some dreams you'll remember for years, decades even, while you forget what you did last Tuesday. The brain tags certain dreams as significant, worth preserving, perhaps because of their emotional intensity or strange beauty or unsettling quality. This realness of dream suggests something profound about all experience. Reality is constructed. Even when you're awake, you're not directly perceiving the external world. You're experiencing a simulation your brain creates from sensory data. Dreams reveal this usually invisible process. They show you what experience looks like when it is purely brain-generated, unmixed with sensory input. And the fact that dreams feel as real as waking shows how thoroughly your brain constructs all your experience, sleeping and waking. Over the course of this journey together, we're going to explore dreams from many angles: scientific, psychological, cultural, philosophical. We'll look at what happens in your brain during sleep, why dreams might exist, what they contain, how they relate to memory and learning and creativity. We'll visit the strange territories of nightmares and lucid dreams. We'll explore what different cultures have believed about dreams throughout history. But this exploration isn't about stripping away mystery. Science doesn't diminish wonder, it deepens it. Knowing how something works can make it more amazing, not less. When you understand the complexity of dreaming, when you realize the extraordinary things your brain does every single night, dreams become more wonderful, not less. Think of it like understanding how music works. Learning about harmony, rhythm, composition doesn't make music less beautiful. It makes you appreciate the artistry more deeply. You hear things you didn't notice before. The beauty increases with understanding. Dreams are similar. The more you know about them, the more remarkable they become. We'll move through this material gently, at a pace that allows for rest. Some information will be more scientific: brain regions, neurotransmitters, sleep stages. Don't worry about memorizing or fully understanding every detail. Let the information wash over you. What resonates will stay, what doesn't will drift away. The goal isn't to become an expert on dreams, but to develop appreciation, curiosity, a sense of wonder about this nightly experience. And as we explore, you'll notice something: the material itself is sleep-inducing. Not because it is boring, but because it is designed to be. The tone, the pacing, the rhythm of the language, all crafted to support your descent into sleep. You're learning about dreams while moving toward dreams. The content and the container match. So you don't need to stay alert, don't need to focus intently. You can let yourself drift. If you miss sentences or whole sections because you're falling asleep, that is perfect. That is exactly right. This isn't a test. There is no wrong way to listen, whether you hear everything or only the first few chapters before sleep takes you, whether you remember the information or let it go completely. All of that is fine. What matters is this. You're here now, resting, allowing yourself to be curious about dreams without pressure to understand them completely. You're honoring sleep, honoring dreams, honoring the nightly journey your consciousness takes. And that honoring, that gentle attention, that is enough. That is everything. So let's continue. Let's descend together into the science and mystery of dreams. Slowly, peacefully, allowing curiosity and rest to coexist. The dreams are waiting. The sleep is near. And you, right now, are perfectly positioned between waking and dreaming, ready to explore both. The journey into sleep begins subtly, almost imperceptibly. You are lying down, comfortable, perhaps listening to these words. Your body starts to relax. This relaxation isn't something you do consciously. It happens to you, your nervous system shifting from sympathetic alert, active, to parasympathetic, calm, restful. Your heart rate slows slightly. Your breathing deepens and becomes more regular. Your body temperature begins to drop by a degree or two. Cooling that helps initiate sleep. In your brain, waves are changing. If you were hooked up to an EEG machine, we DC beta waves. Fast, irregular, the signature of alert waking consciousness, giving way to alpha waves. Alpha waves are slower, about 8 to 12 cycles per second, associated with relaxed wakefulness. This is the state you enter when you close your eyes and let your mind rest without falling asleep. Meditation often produces alpha waves. Daydreaming, that peaceful floating feeling before sleep, takes you. As you drift further, alpha waves give way to theta waves, slower still, about 4 to 8 cycles per second. Theta marks the transition zone, the threshold between waking and sleeping. Your thoughts become less linear. Images might flash through your mind, hypnagogic hallucinations, brief dream-like experiences as your brain begins its nightly journey into imagination. You might see colors, shapes, faces, scenes. These aren't yet full dreams, just previews, your visual cortex warming up. Sometimes as you are falling asleep, your muscles suddenly jerk, a hypnic jerk or sleep start. Your leg kicks, or your whole body twitches, sometimes waking you briefly. Scientists aren't entirely sure why these happen. One theory, as your muscles relax and your brain stem registers this relaxation, it misinterprets the data as falling and triggers a catch reflex. Your body jolting to save you from a fall that is happening. These jerks are completely normal, though sometimes startling. You might also experience the sensation of falling itself, or of floating, or of your body feeling heavy and sinking into the mattress. These are all normal phenomena at the sleep threshold. Your proprioception, your sense of where your body is in space, is changing as your brain shifts modes. The usual feedback loops between body and brain are loosening. You are letting go of waking's tight control, allowing sleep's different relationship with the body to establish itself. Your eyes are probably closed now, or if they still open, they heavy, lidded and unfocused. Behind closed lids, your eyes might move slowly, slow rolling eye movements that characterize drowsiness. You are not tracking anything visual, this is just your eye muscles relaxing, responding to the changing brain state. The room around you is fading, sounds become more distant, less distinct. You might still hear things, ambient noise, maybe these words, but they not pulling your attention the way they would if you were fully awake. You are descending gently through layers of consciousness, moving from waking towards sleep proper. This transition zone can last a few minutes or much longer, depending on how tired you are, how relaxed, how quiet your mind is. And soon, very soon now, you'll cross the threshold completely. You'll let go of the last thread of waking consciousness and enter stage 1 sleep, the beginning of the night's architecture. Stage 1 sleep is brief, usually just a few minutes. It is the lightest stage of sleep, the shallowest. If someone woke you from stage 1, you might not even realize you deep in asleep. You might say you were just resting, just drifting. Brain waves are primarily theta now, slower than waking, but not yet the deep, slow waves of deeper sleep. You are genuinely asleep in stage 1, but barely. You are easily awakened by sounds or movement. Your muscle tone is reduced but not eliminated. Your awareness of the external world has dimmed but not disappeared. This is sleep. Esanterum, the space you pass through on your way deeper, and then you descend into stage 2, a more definite sleep state. Stage 2 comprises about 50% of your total sleep time across the night. It is where you spend the most time. Your brain waves continue to slow, dominated by theta waves, but now punctuated by 2 distinctive features, sleep spindles and K complexes. Sleep spindles are sudden bursts of rapid brain activity, brief spurts of faster waves that appear on EEG as little spindle-shaped spikes. They last just a second or two but occur repeatedly throughout stage 2. Scientists believe sleep spindles play a role in memory consolidation. They seem to help transfer information from short-term to long-term storage, taking experiences from the day and filing them into permanent memory. Sleep spindles also help keep you asleep, protecting your sleep from disruption by external noises. Your brain is actively working to maintain sleep. K complexes are sharp, sudden waves, a high amplitude spike followed by a dip on the EEG. They are the largest brain waves in healthy sleep. K complexes can be triggered by external stimuli, a sound for instance, and may represent your brain checking, is this something I need to wake up for? Usually the answer is no, and sleep continues. K complexes also seem involved in memory processing and cortical development. In stage 2, your body temperature continues dropping. Your heart rate slows further. Your breathing is regular, slower than waking. Your muscles are more relaxed. You are clearly asleep now. Anyone looking at you would see you are sleeping. Awakening, you would take more than a whisper. It would require a louder sound or physical touch, but you are not yet in the deepest sleep. You are still in a relatively light stage, hovering in the middle depths of the sleep ocean. Your brain is doing important work here, consolidating memories, processing information, maintaining the sleep state, but you haven't yet reached the restorative depths of slow, wave sleep. Stage 2 cycles in and out throughout the night. You don't just pass through it once. You'll return to stage 2 multiple times, between periods of deep sleep and REM. It is a hub stage, a baseline, that you return to repeatedly as your sleep cycles, through its various depths and heights. Understanding stage 2 helps you appreciate that sleep isn't a uniform state, but a constantly shifting process. Your brain moving through different modes all night long, each serving different purposes, all necessary for true rest. Now we descend to the deepest level, stage 3 sleep, also called slow wave sleep or deep sleep. This is the most restorative sleep stage, the one that makes you feel truly rested when you wake. If you've ever had a night of poor sleep where you wake feeling exhausted, despite lying in bed for 8 hours, you probably didn't get enough deep sleep. This stage is where the body does its deepest healing. Brain waves in stage 3 are delta waves, slow, high amplitude waves that dominate the EEG. Delta waves cycle at about 0.5-4 times per second, far slower than any waking brain rhythm. They resynchronized, vast populations of neurons firing together in slow rhythm, creating waves that roll through the cortex like ocean swells. This synchronization is part of what makes stage 3 so restorative. Your brain is taking a break from the fragmented, rapid firing of waking consciousness, settling into a deep, coordinated rhythm. You are very difficult to wake from stage 3. A soft sound one. Do it. Even moderate noise might not rouse you. If you are awakened from deep sleep, you'll be groggy, disoriented, confused. This grogginess is called sleep inertia. Your brain was so deeply asleep that it needs time to transition back to waking. You might not know where you are, might struggle to form coherent thoughts for several minutes. This is why alarms that wake you from deep sleep feel particularly harsh. During deep sleep, your body is actively healing. Growth hormone releases primarily during this stage. In children, this fuels growth. In adults, It promotes tissue repair, muscle recovery, bone strengthening. If you exercise, your muscles repair themselves during deep sleep. If you are ill, your immune system works overtime during deep sleep, which is why sleep is so important when you are sick. Your body temperature reaches its lowest point during deep sleep. Your blood pressure drops. Your breathing is slow and regular. Blood flow to your muscles increases, delivering oxygen and nutrients for repair. Your brain's lymphatic system activates, a waste clearance system that flushes out metabolic byproducts accumulated during waking. Toxins that build up while you are awake, including proteins associated with Alzheimer's disease, are cleared away during deep sleep. Your brain is literally cleaning itself. Deep sleep is most abundant in the first half of the night. Your first sleep cycle typically includes a substantial period of stage 3, maybe 20 to 40 minutes. As the night progresses, deep sleep periods get shorter and eventually disappear. Later cycles contain mostly stage 2 and REM. This front loading of deep sleep makes sense. Your body needs physical restoration first, then later focuses on REM's psychological and cognitive functions. Children need more deep sleep than adults. Their bodies are growing, developing, requiring more restoration. As you age, deep sleep declines. Older adults get less stage 3 sleep, which partially explains why they often feel less rested. But at any age, deep sleep is precious. It is the foundation of physical health, the stage where your body recovers from the day's wear and tear right now. Hours from now, actually. When you finally fall asleep, you'll descend into this deep rest. Your brain will slow into delta rhythms. Your body will begin its nightly repairs, and you'll be so deeply unconscious that the world could continue around you, and you would notice. This isn't just rest, it is restoration, renewal. The body's own healing time. Sleep isn't linear, you don't. Descend from stage 1 to stage 2 to stage 3 and then stay there until morning. Instead, your sleep cycles. You move through stages in a pattern that repeats approximately every 90 minutes throughout the night. Understanding this cycle helps you appreciate sleep's complex choreography. A typical cycle begins as you fall asleep. You enter stage 1 briefly, then stage 2, then descend into stage 3, deep sleep. You might spend 20 to 40 minutes in deep sleep during the first cycle. Then you ascend, not back to waking, but up through stage 2 again, and then into a completely different state, REM sleep. This first REM period might be brief, just 5 to 10 minutes. Then you cycle back down, stage 2, maybe stage 3 again, back up to stage 2, then REM, and so on. Each cycle takes about 90 minutes, though this varies. Anywhere from 70 to 120 minutes is normal. Some people have consistently shorter cycles, others have longer ones. Your cycles might vary within a single night, but 90 minutes is the average, and most people complete 4 to 6 cycles per night during a full 7 to 9 hours of sleep. The cycles aren't identical. As the night progresses, their composition changes. Early cycles are deep, sleep heavy. Lots of stage 3, short REM periods. Later cycles flip, stage 3 disappears, stage 2 dominates, and REM periods grow longer and longer. Your final REM period before waking might last 30 to 40 minutes, a long, vivid dream period. This is why you often wake from dreams in the morning. Morning sleep is REM dense. This cycling serves different purposes at different times. Early night's deep sleep handles physical restoration. Later night's extended REM handles psychological processing, memory consolidation, emotional regulation. Your brain needs both, needs them in sequence, needs the rhythm of cycling between states. Interrupt the cycles with noise, light, stress, sleep disorders, and you don't get the full benefits of sleep. Your brain does need your conscious input to manage these cycles. It does this automatically, governed by complex interactions between brain regions and neurochemical systems. The brainstem, hypothalamus, thalamus, and cortex coordinate to produce the cycling. Adenosine accumulation promotes sleep depth. Body temperature rhythms influence timing. Hundreds of factors contribute, all operating outside your awareness. You can trust this process. Your brain has cycled through sleep stages every night of your life. It knows what it is doing. Even if your sleep feels disrupted, even if you wake during the night, your brain is still attempting to cycle properly. As long as you give it time and appropriate conditions, darkness, quiet, comfort, it will cycle you through the stages you need. So as you drift towards sleep tonight, know that this ancient rhythm awaits. You descend and ascend, descend and ascend, 4, 5, 6 times. Each cycle, a complete journey through sleep. Territories. Your brain conducting itself through a symphony of states, each movement necessary, each playing its part in the music of rest. Understanding sleep cycles matters because it affects how you experience sleep and waking. If you ever woken naturally feeling refreshed versus woken to an alarm feeling awful, sleep cycles are why. Waking naturally usually happens at the end of a cycle, when you surface through stage 2 or from REM into very light sleep. You are close to waking anyway, so the transition is smooth. You open your eyes, you are alert relatively quickly, you feel rested. But waking from deep sleep, from stage 3, is harsh. Your alarm goes off while you are in delta, wave territory, and your brain has to lurch from the deepest rest to full alertness. This creates sleep inertia, grogginess, confusion, difficulty thinking clearly. You might feel worse than if you gotten less total sleep but woken from a lighter stage. Sleep quality isn't just about hours, but about where in the cycles you wake. Some people use sleep apps or trackers that monitor movement and wake you during light sleep within a target window. The idea is to avoid deep sleep awakening. While these aren't perfect, they infer sleep stages from movement rather than measuring brain waves directly. They can help. Or you can simply calculate. If sleep cycles are about 90 minutes, then 6 hours, 4 cycles, or 7.5 hours, 5 cycles, might leave you feeling better than 7 hours, which might catch you mid. But here is what is most important. Your brain wants to complete cycles. If you give it enough time, if you don't disrupt sleep with noise or light or stress, it will cycle properly. You don't need to do anything. Your sleep architecture builds itself automatically, reliably, night after night. Chronic sleep deprivation disrupts cycles. If you consistently don't sleep enough, your brain tries to compensate, emphasizing deep sleep at the expense of REM, or catching up on missed REM through longer, more intense REM periods, REM rebound. These compensations show how important each stage is. Your brain doesn't skip stages willingly. It fights to get what it needs. Certain substances disrupt cycles too. Alcohol might help you fall asleep, but fragments sleep later in the night and suppresses REM. You might spend more time in light sleep, less in deep and REM, waking feeling unrested despite sleeping. Many sleep medications have similar effects. They produce unconsciousness, but not natural sleep architecture. Your brain is sedated, but not truly cycling through its natural stages. Tonight, if you allow yourself to sleep fully and naturally, your brain will cycle. First descent into deep sleep, repairing your body. First brief, REM. Second cycle, more repair, longer REM. Third, fourth, fifth cycles. Increasingly REM, heavy consolidating memories, processing emotions, perhaps creating the vivid dreams you might remember when you wake. You need to think about cycles or monitor them or worry whether they re-happening correctly. They will happen. Your brain knows this dance intimately. It has been performing it since before you were born. Even fetuses show sleep cycling. Trust it. Let it work. Your only job is to lie down. Close your eyes. Let go. The cycles will take care of themselves, carrying you through the night. Necessary rhythms, bringing you back to morning rested and renew. In 1953, a graduate student named Eugene Aserinsky was monitoring sleeping subjects with EEG, studying the slow, uneventful brain activity of sleep. Then, several times each night, something strange happened. Sleepers' eyes began moving rapidly beneath closed lids, darting back and forth as if watching something. This was peculiar. Aserinsky and his advisor, Nathaniel Kleitman, decided to wake people during these eye movement periods. to see what they were experiencing. Almost everyone awakened during rapid eye movement periods reported vivid dreams. They described detailed stories, visual scenes, complex narratives. When awakened during other sleep stages, people rarely remembered dreams or reported only vague, thought-like content. But these rapid eye movement periods, which they termed REM sleep, were clearly associated with dreaming. This was a revolutionary discovery. For the first time, scientists could identify when dreaming was likely occurring, creating the possibility of studying dreams scientifically. Your eyes are moving during REM because you are watching the dream. Your visual cortex is generating imagery, and your eye muscles respond, tracking movement and scanning scenes just as they would during waking vision. If you are dreaming about a tennis match, your eyes might move left, right, following the ball. If you are dreaming about climbing stairs, your eyes might move upward. The correlation is T-perfect, but it is real. Your eyes are engaged with dream content, the only voluntary muscles that aren't T-paralyzed during REM. Why aren't your eyes paralyzed like the rest of your body? We're not entirely sure, but it might be that eye movements are too important to shut down. Even in sleep, your eyes serve functions like distributing tears across the cornea. Or perhaps the paralysis mechanism specifically targets muscles that could cause large movements, and eye muscles, being small and enclosed, don't trigger the same protective paralysis. REM sleep isn't T-continuous. It comes in periods, throughout the night, cycling with other sleep stages. Your first REM period might last only 10 minutes, but as morning approaches, REM periods lengthen. Your final REM before waking could last 30 to 40 minutes. A substantial dream session. Total REM across a full night. Sleep amounts to about 90 to 120 minutes, roughly 20 to 25% of total sleep time. During REM, if someone could watch you sleep, they notice several things. Your closed eyes moving rapidly, your breathing becoming irregular, your body completely still, except for occasional twitches in fingers or toes. You look like you are experiencing something intense, which you are. You are dreaming. Your brain is creating entire worlds, and your body is locked down to keep you safe while you explore those worlds. This discovery of REM opened the door to modern sleep research. For the first time, scientists could correlate brain activity with subjective experience. They could wake people at specific times, gather dream reports, look for patterns. Nearly 70 years later, we know vastly more about REM and dreaming, yet mysteries remain. REM is when most vivid dreams occur, but we still don't fully know why we need it, why it evolved, why it takes the form it does. The eyes move, the brain activates, the body paralyzes, and consciousness ventures into territories that don't exist anywhere in the external world. French researchers Michel Jouvet gave REM sleep a different name, sommeil paradoxical sleep. The name captures something essential about this state. REM is paradoxical because it combines features that seem contradictory. Your body deeply asleep, while your brain highly active, a state of profound unconsciousness that is also intensely conscious. Look at an EEG of REM sleep, and it resembles waking more than sleeping. Brainwaves are fast, irregular, desynchronized, similar to the pattern of alert wakefulness. Beta and gamma waves appear, the same frequencies associated with focused attention and conscious awareness when you're awake. If you only looked at EEG without other information, you might think the person was awake, possibly even concentrating intently on something. But the person isn't awake, they're deeply asleep, unresponsive to external stimuli. Speak to someone in REM and they won't respond. Touch them and they might not wake. They're as disconnected from the external world as they are during deep sleep, perhaps more so. Yet their brain is lit up like Times Square, burning energy at rates comparable to or exceeding waking metabolism. Other physiological measures show this paradoxical activation. Heart rate becomes irregular, sometimes rapid. Blood pressure fluctuates, sometimes increasing to waking levels or higher. Breathing becomes irregular, shallow then deep, fast then slow. In men, penile erections occur almost universally during REM. In women, increased vaginal blood flow occurs. These aren't sexual responses, their autonomic nervous system activity, signs of the intense physiological arousal happening during REM. Body temperature regulation changes too. During REM, you temporarily lose the ability to regulate temperature through shivering or sweating. You become briefly poikilothermic, like a reptile, your body temperature drifting toward ambient temperature. This is why room temperature matters for sleep. If it is too hot or cold, REM periods might be shortened or disturbed because your body can't maintain comfortable temperature during these periods. All this activation happens while your voluntary muscles are paralyzed. The technical term is REM atonia, complete loss of muscle tone throughout the body, except for the diaphragm, so you can breathe, and the extraocular muscles, so your eyes can move. This paralysis is active, not passive. Your brain stem deliberately sends inhibitory signals to motor neurons, blocking all voluntary movement. Without this paralysis, you'd act out dreams physically running, fighting, flying, whatever the dream contains. The paradox deepens when you consider subjective experience. You're having vivid, complex experiences, seeing, hearing, feeling, thinking, reacting emotionally. You're conscious in the sense that there is something it is like to be you during REM. You're having experiences, even if you don't remember them upon waking. Yet you're unconscious in the sense that you're not aware of external reality, not responding to environment, not monitoring or controlling yourself. REM is a third state of being, distinct from both waking and other sleep stages. Not quite conscious, not quite unconscious, but something in between or beyond both. A hybrid state where the brain's machinery of consciousness runs without its usual inputs, creating experiences from pure internal activity. This is paradoxical sleep, simultaneously the deepest rest and the most active consciousness, the brain more alone than ever yet, creating the richest experiences of the night. During REM sleep, you cannot move. Your arms lie still at your sides or curled under your pillow. Your legs rest motionless. You can't roll over, can't adjust position, can't scratch an itch. This paralysis, REM atonia, is one of REM sleep's most important features, protecting you from the dream experiences your brain is generating. The paralysis originates in your brain stem, specifically regions like the sublattidorsal nucleus. During REM, these areas release neurotransmitters, primarily GABA and glycine, that inhibit motor neurons in the spinal cord. Motor neurons are the final pathway between brain and muscles. If they're inhibited, no movement occurs no matter what your brain commands. Your motor cortex might be firing, telling your legs to run, but the message stops at the spinal cord. Nothing reaches the muscles. This protection is necessary. Studies of animals and rare humans with REM behavior disorder show what happens when atonia fails. Cats with lesioned brainstems, disabling the atonia mechanism, act out dreams while sleeping. They run, pounce, fight, hunt, all while fully asleep. It looks bizarre and is potentially dangerous. Humans with REM behavior disorder do the same, punching, kicking, leaping from bed, injuring themselves or partners. These people are genuinely asleep, genuinely dreaming, but their bodies aren't paralyzed. Most people's paralysis works perfectly, night after night. You dream about running. Your body lies still. You dream about fighting. Your muscles don't tense. You dream about flying. You don't flail your arms. The paralysis is so complete, you're not even aware of your body during many dreams. You might not notice whether dream you has a body. You're just experiencing disembodied consciousness, watching or participating in events. Occasionally, paralysis and consciousness get out of sync, creating sleep paralysis. This happens when you wake while REM atonia is still active. You're conscious, aware of your bedroom, able to open your eyes, but completely unable to move. This is terrifying when it happens. You might feel pressure on your chest, sense a presence in the room, see shadowy figures. These are hypnopompic hallucinations, fragments of REM mentation bleeding into waking. Your body is still generating dream content while you're partially awake. Sleep paralysis has inspired countless cultural beliefs: night demons, alien abductions, ghostly visitors. Before modern neuroscience, people experiencing sleep paralysis reasonably attributed it to external agents. Something must be holding them down. Now we understand it is just a timing mismatch. The paralysis mechanism hasn't released yet, though consciousness has returned. It is harmless, though disturbing. Usually it lasts only seconds or minutes. ending as the brain fully transitions to waking. The paralysis spares only essential muscles. Your diaphragm continues working, contracting rhythmically to move air in and out of lungs. If you stop breathing during sleep, you die. The paralysis mechanism evolved to allow breathing while blocking other movements. Your heart keeps beating. Obviously, cardiac muscle operates automatically, not subject to voluntary control, and your eyes can move, tracking dream imagery, though you can't voluntarily move them during REM any more than you can voluntarily move your arms. This protective paralysis is elegant, shutting down movement while preserving life-essential functions, keeping you safe from dream-induced actions, while allowing the dream experience to unfold fully. Your brain can generate any scenario, any action, any experience, and your body won't respond. You're free to dream anything, safe in the knowledge that dreams remain internal, mental, harmless to your sleeping body. During REM sleep, your brain reorganizes. Certain regions become highly active, others quiet down. This reorganization creates the unique characteristics of dreams, their vivid visuals, intense emotions, bizarre logic, and lack of self-awareness. Understanding which brain regions are active helps explain why dreams feel the way they do. Your visual cortex, located in the back of the brain in the occipital lobe, is intensely active during REM. This makes sense. Dreams are primarily visual experiences. When you dream, you see things, faces, places, colors, movements, scenes unfolding before you. This visual experience is generated by your visual cortex working without any input from your eyes. The cortex is firing patterns similar to those produced by actual vision, creating imagery from pure neural activity. This is why dreams are so visually convincing. The same machinery that processes real sight is creating dream sight. Your amygdala, the emotional center of the brain, is also highly active during REM, sometimes more active than during waking. The amygdala processes fear, anxiety, and other strong emotions. Its high activity in REM explains dreams' emotional intensity. Dreams often feel more emotionally charged than waking experiences. Fear in dreams can be overwhelming terror. Joy in dreams can be euphoric. The amygdala is running hot, generating emotions that flood the dream with feeling. Your hippocampus, critical for memory, is active during REM, accessing stored memories and replaying them. This is why dreams often contain elements from your life, people you know, places you've been, concerns you have. Your hippocampus is pulling up memories, and these memories become raw material for dreams. The memories might be recent, day residue, or old, sometimes surprisingly, older childhood memory, resurfacing in a dream decades later. Your motor cortex, which plans and coordinates movement, is active during REM, firing as if you're moving even though your body is paralyzed. This creates the sensation in dreams of running, flying, fighting, walking, reaching. Your brain is simulating movement, and the simulation feels real because the motor cortex is genuinely active, just disconnected from actual muscles. Meanwhile, your prefrontal cortex, the front part of the brain responsible for logic, planning, self-awareness, and executive control, is relatively quiet during REM. This is crucial for dream phenomenology. The prefrontal cortex is what makes you rational, self-aware, able to plan and monitor yourself. When it is quiet, you lose critical thinking and self-monitoring. This is why dreams are so illogical, why you don't question impossibilities, why you lack awareness that you're dreaming. In dreams, someone can suddenly become someone else, and you don't question it. You can fly, and you accept this as normal. You're in your childhood home, that is also your office, and the contradiction doesn't trouble you. Your prefrontal cortex, which would normally say, "Wait, that doesn't make sense," is offline. You're experiencing without judging, perceiving without analyzing, immersed completely without distance or perspective. This pattern of activation, visual cortex on, amygdala on, hippocampus on, motor cortex on, prefrontal cortex off, creates the dream experience. It is a specific configuration of consciousness, different from waking, where prefrontal cortex is active, and different from other sleep stages, where most cortex is quiet. REM creates its own state, its own flavor of awareness, shaped by which brain regions are participating and which are silent. REM sleep isn't evenly distributed across the night. It appears in cycles, and those cycles change dramatically from early night to late night. Understanding this progression helps you appreciate why morning dreams are often the most vivid and memorable. Your first REM period occurs about 90 minutes after falling asleep, at the end of your first sleep cycle. This initial REM is brief, maybe just 5 to 10 minutes. It is almost a preview, a short sample of what is to come. You might dream during this period, but the dream is likely short, fragmentary, perhaps not memorable. Your brain is easing into REM, testing the state, not yet fully committed. As you cycle through the night, each REM period gets longer. Your second REM might last 15 to 20 minutes. Your third, 20 to 25 minutes. By your fourth or fifth cycle, REM periods can last 30 to 40 minutes. Substantial dreaming sessions. Meanwhile, deep sleep stage 3 diminishes and eventually disappears. Early night is deep, sleep dominant. Late night is REM dominant. This progression makes functional sense. Deep sleep handles physical restoration, tissue repair, immune function, growth hormone release. Your body needs this first, getting the physical maintenance done. Then, as the night progresses and physical restoration is largely complete, your brain shifts priority to REM-S functions: memory consolidation, emotional processing, neural network reorganization. By morning, you are spending most of your time in stage 2 and REM, cycling between light sleep and extended REM periods. This is why you often wake from dreams in the morning. You are waking from a long REM period that might have lasted 30 to 40 minutes. Plenty of time for a complex narrative dream. These late morning dreams are the ones you are most likely to remember, both because they re-long and detailed, and because you wake directly from them without intervening sleep stages to blur the memory. If you are REM deprived, sleeping too little, or having fragmented sleep, your brain will compensate through REM rebound. The next time you sleep well, you'll get increased REM, your brain making up for missed REM time. This happens automatically. You don't control it. Your brain tracks its REM deficit and works to resolve it. This compensation shows how important REM is. Your brain does casually skip REM. It fights to get enough. All mammals experience REM sleep, suggesting it is evolutionarily ancient and important. Dolphins and whales have minimal REM, possibly because they need to surface to breathe and can risk deep paralysis. But most mammals, cats, dogs, rats, primates, show clear REM with the same characteristics: rapid eye movements, muscle atonia, activated brains. They read dreaming too, presumably, though we can ask them what they experience. Tonight, when you finally sleep, this progression will unfold. First cycle, decent deep sleep, brief REM. Second and third cycles, less deep sleep, more REM. Final cycles before morning, almost no deep sleep, extended REM periods. You'll dream most in the hours before waking, your brain in extended REM, creating the vivid, strange, memorable dreams that you might carry into your day. This is your brain's natural rhythm, perfected over millions of years, reliable as sunrise, waiting to carry you through the night. Evolution is economical. It doesn't maintain expensive processes without reason. If a trait or behavior costs energy but provides no benefit, natural selection eliminates it over generations. REM sleep is expensive. Metabolically, your brain burns nearly as much energy during waking. REM is time consuming, taking up 20 to 25% of sleep, which is 1.5 - 2 hours nightly, which amounts to about 6 years over an average human lifetime. And REM involves risk. You are paralyzed, vulnerable, unable to respond to threats while dreaming. Despite these costs, REM persists. Every mammal, except the few aquatic exceptions, experiences REM. Humans deprived of REM show cognitive and emotional impairments. REM deprivation in animals causes stress, and if continued long enough, death. Clearly, REM does something important. But what, and why does it take this particular form? The rapid eye movements, the brain activation, the paralysis, the subjective experience of dreaming. The honest answer, we're not certain. We have theories, multiple competing theories, each supported by some evidence, but none universally accepted. This uncertainty might seem frustrating, but it is actually the natural state of complex scientific questions. Complete explanations are rare. Usually we have partial understandings from multiple angles, pieces of a larger puzzle we're still assembling. What is clear is that dreams aren't random noise. A brain doesn't waste energy on meaningless activity. Whether dreams themselves serve a function or are byproducts of other functions, a distinction we'll explore. REM sleep definitely serves crucial purposes, and even if dreams are byproducts, they are consistent, structured byproducts that reveal important things about how the brain works. Different theories emphasize different aspects of REM and dreaming. Some focus on memory, dreams as memory consolidation. Some focus on emotion, dreams as emotional processing or threat simulation. Some focus on neural maintenance, REM as a period of brain development and network optimization. Some focus on consciousness, dreams as the brain as self-generated virtual reality. Each theory captures something true, but probably not the whole truth. Perhaps the question, why do we dream, assumes a single answer when really there are multiple answers. Evolution often finds multiple uses for the same structure or process. Dreams might serve several functions simultaneously, consolidating memories while processing emotions, while maintaining neural plasticity, while doing other things we haven't discovered yet. Function might be plural, not singular. Or perhaps dreams themselves don't have a function. Perhaps REM has functions, and dreams are the subjective experience of those functions. The way pain is the subjective experience of tissue damage. Pain is purposeful in itself. It is the experience of something purposeful damage detection. Similarly, dreams might not be purposeful in themselves, but the experience of purposeful processes like memory replay. Either way, exploring theories about dreams illuminates the dreaming brain. Each theory reveals something interesting, something true about what happens when we dream. And the not knowing for certain, the remaining mystery, that is fine. Mystery isn't failure. It is invitation, space for wonder, recognition that consciousness and sleep and dreams are complex enough to keep surprising us. One of the most well-supported theories about REM and dreams is that they serve memory consolidation. During waking, your brain constantly encodes new information. Things you see, hear, experience, learn. These memories initially exist in fragile, temporary form in the hippocampus. They need to be transferred to long-term storage in the cortex, a process called consolidation. And consolidation happens primarily during sleep, especially during REM. During REM, your hippocampus replays experiences from the day. Neural patterns that fired during learning fire again, often faster than real time. If you learned a new skill or encountered new information, those patterns replay during REM, the memory being rehearsed, strengthened, transferred to cortical storage. Brain scans show these replay events happening. Researchers can actually see the same patterns firing during sleep that fired during waking learning. Dreams, in this view, are what you experience while consolidation happens. The fragmented, often bizarre nature of dreams reflects the brain pulling up different memories, comparing them, connecting them, filing them. You dream about recent events because those memories are being processed. You dream about strange combinations. Today's meeting in your childhood bedroom because your brain is linking new memories to old ones, finding patterns, building associations. This theory explains several dream phenomena. Day residue, dream content from recent experiences. Makes sense if the brain is processing recent memories. The emotional intensity of dreams makes sense because emotionally significant events are prioritized for consolidation. Memory researchers know emotional events are better remembered. Dreams might be the mechanism that creates this priority. Studies support memory consolidation theory strongly. People who sleep after learning perform better than those who stay awake. The sleep benefit is particularly strong for declarative memories, facts, events, and procedural memories, skills, how to knowledge. Naps containing REM improve memory more than naps without REM. Students who study then sleep before tests perform better than students who stay awake studying longer. Even specific memories can be enhanced during sleep. Researchers have played sounds or scents during learning, then replayed them during sleep, finding that the associated memories were strengthened more than memories without the cue. This technique, targeted memory reactivation, shows that specific memories are being accessed and consolidated during sleep. Skills improve overnight too. Musicians practice a piece, sleep, then find they can play it better the next day without additional practice. Athletes visualize movements, sleep, then show improved performance. Even complex problem-solving improves. People given puzzles at night, told to sleep on them, often solve them after sleeping, as if sleep provided insight. REM's role isn't exclusive. Other sleep stages, particularly stage 2 and deep sleep, also contribute to consolidation. But REM seems especially important for integrating memories, connecting disparate elements, finding meanings and patterns. REM is when the brain gets creative with memories, not just storing them but reorganizing them, discovering relationships, building the vast associative networks that comprise your knowledge. So, as you sleep tonight, your brain will review your day. Conversations you had, things you learned, experiences that mattered, all will be replayed, rehearsed, gradually moved from temporary to permanent storage. Dreams are your subjective awareness of this process, the conscious mind watching as memories surface, combine, reorganize. You are witnessing your brain do its nightly filing, organizing the library of your life. Another major theory proposes that REM and dreams exist primarily for emotional processing. This theory notes the amygdala's high activity during REM and the emotional intensity of dreams. It suggests that REM provides a unique neurochemical context for processing emotional experiences without being overwhelmed by them. During waking, the neurotransmitter norepinephrine, associated with stress and alertness, is present in your brain. During REM, norepinephrine levels drop to near zero. This creates unusual conditions: high amygdala activity, emotional processing, with low norepinephrine, low stress response. You can experience emotional scenarios without the full physiological stress response. It is like practicing emotions in a safe context. Dreams often replay emotional situations, conflicts, anxieties, fears, desires. You might dream about a difficult conversation, or a threatening situation, or losing someone you love. These dreams feel emotionally real. Your amygdala is responding as if the events were real. But the reduced norepinephrine means you're not launching a full stress response. Your body isn't flooding with stress hormones the way it would if you were actually having that conversation or facing that threat while awake. This might allow emotional learning and adaptation. You can process fears, practice responses, work through emotional challenges in a context where failure is safe. The threat simulation theory, a variant of this idea, suggests dreams simulate threatening or challenging scenarios, allowing you to rehearse responses. Ancient humans might have dreamed about predators or conflicts, keeping threat response systems sharp. Modern humans dream about missing flights, failing exams, social embarrassment, modern threats. But the same rehearsal principle, PTSD, provides indirect support for emotional processing theory. PTSD involves disrupted REM nightmares replaying trauma, REM fragmentation, altered sleep architecture. The emotional processing system seems stuck, repeatedly replaying trauma without successfully integrating it. Treatment often involves changing dream content, imagery rehearsal therapy, or processing trauma memories before sleep. When REM's emotional processing works correctly, difficult experiences gradually become less distressing. When it doesn't work, as in PTSD, emotional wounds remain raw. Emotional regulation also depends on sleep, especially REM. After a good night's sleep, emotional reactivity decreases. You handle stress better, respond to provocations more calmly. After poor sleep or REM deprivation, emotional regulation suffers. You're more irritable, more reactive, less able to modulate feelings. This suggests REM is doing something important for emotional balance. Some researchers propose that REM strips emotional charge from memories. Memories don't disappear, but their emotional intensity reduces. You remember difficult events but don't feel them as strongly. This emotional depotentiation might explain why time heals. Not just time, but time with sleep, time with REM processing those emotional memories night after night until they're less painful. Dreams might also problem-solve emotional challenges. You go to sleep worried about something, and overnight your brain works on it. Not consciously, not deliberately, but through dream processes. You wake with new perspective, a shift in feeling, sometimes even a solution. People report getting relationship insights, creative ideas, emotional clarity after dreaming about problems. The brain has been working while you slept, approaching the issue from different angles. Emotional centers engaged without waking's logical constraints. So tonight, whatever emotions you're carrying, stress, joy, anxiety, sadness, excitement, your brain will process them during REM. It will replay emotional moments, simulate emotional scenarios, gradually integrate emotional experiences into your life's narrative. Dreams might be uncomfortable sometimes, emotional to the point of discomfort. But this is processing, this is healing. This is your brain doing its emotional work. Evolutionary psychologists Antti Revonsuo and Cacciavalli proposed a specific function for dreams: threat simulation. Their theory suggests dreams evolved as a biological defense mechanism, simulating threatening events so you could practice responses, keeping survival skills sharp without real danger. Look at dream content, and a pattern emerges. Dreams are rarely about pleasant, mundane activities. You don't often dream about doing laundry or having a nice day at the office. Dreams bias toward negative, threatening, challenging scenarios. Being chased, attacked, threatened. Finding yourself in dangerous situations. Losing things or people. Failing at important tasks. Being exposed or vulnerable. Dreams often feel like mild to moderate nightmares, not always terrifying, but definitely not relaxing. This negativity bias makes sense evolutionarily. Pleasant experiences don't require practice. Enjoying a meal doesn't need rehearsal, but threats do. Predators, conflicts, environmental dangers, these required quick, effective responses in ancestral environments. Individuals who could practice responses in dreams, keeping threat detection and response systems active, might have had survival advantages over those who didn't. Children's dreams support this theory. Young children dream heavily about animals, especially threatening animals. Even if they've never encountered such animals, they dream about being chased, about monsters, about threats. This might be innate programming, brains rehearsing ancestral threats, predators even in modern safe environments. As children age, threats in dreams shift toward more social and realistic concerns, school tests, social embarrassment, contemporary dangers. But the threat rehearsal function continues. Modern dreams reflect modern threats. You might not dream about lions, but you dream about missing flights, failing exams, showing up naked to important meetings, car brakes failing, losing your job. These are updated threats, reflecting contemporary anxieties, but serving the same function, rehearsal. Your brain simulating problems, testing responses, keeping you prepared for challenges. Critics note that not all dreams are threatening. Many dreams are neutral, mundane, or positive. And the theory doesn't explain bizarre dream elements that don't relate to threats. Why does dream logic create impossible scenarios if the point is realistic threat rehearsal? But proponents respond. Even non-threatening dreams often involve challenges, problem-solving, navigating complex situations. And the bizarreness might be necessary. Loose associations and strange combinations allow creative problem-solving, testing novel responses rather than just rehearsing rigid behaviors. Nightmares, the most intensely threatening dreams, might be the system working overtime. Occasional nightmares could be beneficial threat simulation. Frequent nightmares might indicate the system is overactive, perhaps because you're experiencing excessive stress or trauma that the system is struggling to process. PTSD nightmares represent the system stuck, replaying trauma obsessively without successful resolution. Lucid dreamers sometimes turn nightmares into opportunities. Recognizing their dreaming, they confront dream threats deliberately, using the dream as explicit practice. Some therapists teach nightmare sufferers to lucid dream specifically to rewrite nightmares, changing outcomes, reducing fear. This therapeutic use aligns with threat simulation theory, using dreams' capacity for simulation to practice better responses. Whether or not threat simulation is dreams' primary purpose, it is clearly something dreams can do. You can experience fear, danger, challenge in dreams, practicing responses without real risk. Maybe evolution specifically designed this function, or maybe it is a side effect of how dreams work, emotional centers active, memories replaying, scenarios generated from concerns, that happens to provide rehearsal benefits. Either way, your more challenging dreams might be doing useful work, keeping you prepared, maintaining skills, testing yourself in simulation. There is a contrarian view worth considering. Maybe dreams don't have a specific purpose. Maybe REM sleep has purposes, but dreams themselves are epiphenomena, byproducts of other processes, the subjective side of something that works for reasons unrelated to dreaming itself. J. Alan Hobson and Robert McCarley proposed the activation synthesis hypothesis in the 1970s. They noted that during REM, the brainstem sends random activation to the cortex. The cortex, receiving these signals, does what it always does, tries to make sense of input. It synthesizes a narrative from the activation, creating dreams. Dreams aren't meaningful communications from the unconscious. They re the cortex's best attempt to create coherent experience from random noise. This might sound dismissive, but it is not denying dreams matter subjectively. Pain is a byproduct of tissue damage. Damage itself is the problem. Pain just signals it. But pain certainly matters to the person experiencing it. Similarly, even if dreams are byproducts of REM's memory consolidation or neural maintenance functions, they still matter to you. They re-still experiences, still part of your conscious life, still potentially meaningful in personal ways even if not biologically purposeful. Recent versions of this idea are more sophisticated. Dreams might emerge from the brain's predictive processing. Your brain constantly predicts what is coming next and updates predictions based on input. During waking, sensory input provides corrections. During REM, there is no sensory input, so predictions run unchecked. Dreams are pure prediction, the brain generating what it expects without reality checking. This explains dream content drawn from memories and expectations, and dream bizarreness, no reality to constrain predictions. This view doesn't deny that memory consolidation, emotional processing, and other functions happen during REM. It just suggests that the subjective experience, the dream itself, isn't the point. You are experiencing the side effects of important processes, not the processes themselves, like you might feel your heartbeat during exercise. The feeling isn't the point. Cardiovascular adaptation is the point. But the feeling is still real and noticeable. Does it matter whether dreams have purpose? Maybe not practically, whether dreams are functional or epiphenomenal. You still dream tonight. They still feel real, still potentially provide insights, still be part of your experience. Biological purpose doesn't determine subjective meaning. You can find meaning in dreams, regardless of evolutionary function. Many people do find personal meaning in dreams, recurring dreams that reflect ongoing concerns, dreams that provide creative inspiration, dreams that feel spiritually significant. These meanings are valid regardless of biological purpose. Dreams don't need to be evolutionarily functional to matter to you personally. Your relationship with your dreams is yours to define. So perhaps the question, why do we dream, has multiple answers or no single answer, or answers that vary depending on what you mean by dream. REM clearly has functions. Memory, emotion, neural development, probably others. Whether the subjective experience of dreaming is itself functional or is a beautiful, meaningful byproduct, maybe that is a question that can remain open. Maybe it is enough to appreciate that you dream, to notice what dreams contain, to let them be what they are without needing to fully explain why. Across all cultures throughout human history, certain dream themes appear again and again. Being chased running from something threatening, unable to escape, falling plummeting through space, sometimes waking with a jolt, flying soaring through air, sometimes joyful, sometimes anxious, being naked in public exposed and vulnerable, embarrassed, taking tests unprepared, sitting for an exam you haven't studied for, questions incomprehensible, teeth falling out, suddenly loose or crumbling, frightening and strange. These themes aren't culturally transmitted. They appear spontaneously in people who've never heard about them. Children dream these themes before learning. They're common. Different cultures, with different languages and traditions, report the same motifs. This universality suggests something deeper than cultural learning, perhaps innate patterns, archetypal concerns, fundamental human anxieties, finding expression through dreams. Evolutionary psychologists suggest these themes reflect ancestral challenges. Being chased, fleeing predators, a constant threat in human evolutionary history. Falling dangerous for tree-dwelling ancestors. nakedness, vulnerability, exposure to danger. These might be residual programming, ancient concerns that still trigger dreaming brain simulation systems, even when no longer relevant to modern life. But themes also adapt to contemporary concerns. Medieval people rarely dreamed about car crashes or airplane malfunctions. Modern people dream about technological failures, social media embarrassments, workplace anxieties. The specific content updates, but underlying themes remain: threat, vulnerability, loss of control, social exposure, failure. These seem to be fundamental human concerns that dreams explore regardless of era or culture. Not everyone dreams all themes. Some people frequently dream about flying, others never do. Some have recurring test dreams decades after leaving school, others don't. Individual dream content varies enormously, but across populations, these themes appear with statistical regularity, suggesting they tap into something shared in human psychology. Interestingly, despite universality, interpretations vary. In some cultures, falling dreams are omens or spiritual messages. In others, they're meaningless brain noise. In psychoanalytic traditions, they symbolize loss of control or failure. In neuroscience, they might reflect vestibular system activation or memory of actual falls. Universal themes, multiple meanings, dreams provide common material that cultures and individuals interpret differently. You'll likely experience some universal themes tonight or in coming nights. If you dream about being chased, it doesn't necessarily mean anything specific. It is a common dream type. Your brain perhaps simulating threat scenarios, processing anxiety, or just generating typical dream content. The theme is universal, but your particular chase dream, who is chasing, why, where, how you respond, that is uniquely yours, shaped by your specific life, memories, concerns. Dreams are autobiographical. They're built from your memories, concerns, experiences. You don't dream about people you've never seen. Though you might create composite characters, you don't dream about places you've never been, though you might combine and distort places you know. Dream material comes from your life, recent and distant, conscious and forgotten, significant and trivial, assembled in novel combinations, but always sourced from your personal database. The day residue effect is well documented. Experiences from the past day or two often appear in dreams. Meet someone new, they might show up in that night's dream. Watch a movie, scenes or themes might infiltrate your dreams. Have an important conversation, you might dream about the person or topic. Recent experiences are fresh in memory, readily accessible, prioritized for consolidation, so they become dream fodder. But dreams also pull from older memories, sometimes surprisingly old. You might dream about someone you haven't thought about in years. Visit a childhood location in a dream, though you've moved far away. Suddenly remember, within a dream, something you'd forgotten while awake. Your brain has access to vast memory stores, and dreams can pull from any of it, combining recent and ancient, explicit and implicit, factual and emotional. Concerns shape dreams powerfully. Medical students dream about anatomy and exams. Pregnant women dream about babies and childbirth. People going through relationship difficulties dream about partners and conflicts. Your waking preoccupations become dream themes. If you're anxious about something, it will likely appear in dreams, perhaps symbolically. Dreams reflect what matters to you, what occupies your mental space. Emotional salience determines what becomes dream content. Neutral events, your commute, routine work tasks, rarely feature in dreams. But emotional events, arguments, celebrations, surprises, fears appear frequently. Your brain tags emotional events as significant, processes them more deeply, incorporates them into dreams. This emotional bias means dreams often feel emotionally intense, even when narratively mundane. Some researchers call dreams hyperassociative, making connections normal waking thought wouldn't make. Your boss's face on your mother's body in your childhood home, bizarre combination, but it reveals associations your mind makes. Perhaps your boss and mother both represent authority. Perhaps the childhood home connects to feelings of safety or judgment. Dreams' weird logic shows how your mind categorizes, what it groups together, what it associates even when waking consciousness doesn't. Cultural context influences dream content too. Americans dream about individualistic concerns. personal achievement, self-expression. East Asian populations dream more about social groups and collective harmony. Urban people dream about buildings and crowds. Rural people dream about nature and animals. Your environment, your culture, your life circumstances, all feed into dream content, creating dreams that are your specific existence. Tonight, your dreams will be yours, built from your memories, reflecting your concerns, shaped by your life. No one else will have exactly your dreams, because no one else has exactly your life. This makes dreams intimate, personal, revealing. They're not messages from external sources, but expressions of your own mind, showing you what it contains, what it is processing, what matters to you right now. Dreams don't follow waking logic. Impossible things happen. You fly without wings, breathe underwater, teleport between locations. People transform, one person becomes another mid-conversation. Scenes shift abruptly. You're at work, then suddenly on a beach, without transition or explanation. Time behaves strangely. Events that should take hours pass in moments, or moments stretch into eternities. Physics is negotiable, gravity fails. Objects morph, spaces expand impossibly. This bizarreness results from how REM reconfigures your brain. Your prefrontal cortex, which maintains logic, monitors consistency, enforces reality, testing, is relatively quiet during REM. You lose critical thinking. When someone in your dream becomes someone else, you don't question it because the questioning mechanism is offline. Dreams bypass your skepticism completely. Memory processes also contribute to bizarreness. During REM, your hippocampus is active, pulling up memories, but it is pulling them loosely associatively. Without the tight organization of waking recall, related memories blend. Your ex-partner's face merges with your mother's. Your childhood home incorporates features of your current office. These aren't symbolic statements. They're just memories stored near each other in your brain's network, getting activated simultaneously and combining. Dream bizarreness might serve creative purposes. With logic suspended, unusual combinations occur. Ideas connect that wouldn't connect during waking's rigid thinking. This might facilitate problem solving, allowing your brain to try mental combinations it would reject as illogical while awake. Some discoveries and creative insights have come from dreams, not because dreams are mystically wise, but because they explore possibility space differently than waking consciousness. Different people experience different levels of bizarreness. Some people's dreams are relatively mundane, realistic scenarios with minor oddities. Others experience wild surrealism, Dooley-like landscapes, impossible physics, profound strangeness. These differences might reflect personality, creativity, brain chemistry, or just chance. Dreams vary person to person as much as they vary night to night. Lucid dreamers often report that gaining lucidity, realizing you're dreaming, increases bizarreness temporarily. The dream becomes more unstable, reality becomes more fluid. This might be because activating prefrontal cortex partially enough for self-awareness disrupts the dream's internal consistency without fully waking you. You're in between states, and reality reflects that liminality. Dream bizarreness has inspired artists for millennia, surrealist painters like Dalí and Magritte, filmmakers like Lynch and Gondry, writers exploring dream logic and impossible narratives. Dreams show that consciousness can operate with different rules, that coherent experience doesn't require logical consistency. You can experience bizarreness fully, without discomfort, accepting all impossibilities as the dream presents them. Tonight, your dreams will likely be strange. Things will happen that can't happen. People will be themselves, and also not themselves. You'll accept all of it until you wake, when waking logic reasserts itself and you think, that was weird. But while dreaming, nothing is weird. Everything makes dream sense, following dream logic, which is its own kind of logic, even when it contradicts waking rules. Vision dominates dreams for most people. You see scenes, faces, colors, movements, visual experience nearly as rich as waking vision, sometimes more vivid. Your visual cortex is generating this imagery without any light entering your eyes, creating pure hallucination that feels completely real. Most dream research focuses on visual content because dreams are primarily visual experiences. But dreams include other senses too. Sound appears in dreams, people speak, music plays, noises occur. Your auditory cortex is active, generating sounds. Some dream sounds are externally triggered. An alarm clock might become part of a dream before waking you. But most are purely internal. Your brain creating auditory experiences from memory and imagination. Touch and bodily sensation occur in dreams. You feel textures, temperatures, pain, pleasure, movement. Your somatosensory cortex is processing these sensations. You might feel wind on your face in a flying dream, the sensation of running in a chase dream, pain if you're injured in a dream. These sensations can be vivid enough to persist briefly after waking. Waking from a dream of being hit, you might feel residual pain where dream you was struck. Taste and smell are less common in dreams, though they do occur. Most people don't remember tasting or smelling in dreams, perhaps because these senses are less central to waking experience, or because the relevant cortices are less active during REM. But some dreams include tastes and smells vividly, eating in dreams, smelling flowers, detecting odors. These sensory elements can be extremely realistic when they appear. Emotional sensation is often the strongest sensory component. You feel emotions intensely in dreams: fear, joy, sadness, confusion, excitement, love, anger. The amygdala's high activity during REM generates these emotions, and they can be overwhelming. You might wake from a dream with emotion still flooding your body, racing heart, tears, euphoria, the emotional experience outlasting the dream itself. Some people experience synesthesia in dreams, senses crossing, seeing sounds or hearing colors. Others experience abstract sensations difficult to describe in waking terms, a sensation of knowing something without perceptual content, or experiencing concepts directly rather than symbolically. Dreams can include types of experience not available during waking consciousness. Congenitally blind people dream without vision. Their dreams emphasize other senses: touch, sound, smell, creating rich, multisensory experiences that don't include visual imagery. This shows dreams aren't essentially visual. They use whatever senses are available. People who lose vision later in life initially dream with vision, but over years, visual dreams fade and other sensory modalities dominate. The brain adapts, dreaming through available channels. Deaf people dream, often in sign language, if that is their primary language. They experience visual communication in dreams just as hearing people experience auditory communication. This shows language in dreams adapts to the dreamer's waking communication mode. Tonight, your dreams will be sensory experiences, primarily visual perhaps, but also including sounds, sensations, emotions, whatever your particular dreaming brain emphasizes. These sensory experiences are hallucinations in the technical sense, percepts without external stimuli, but they're not pathological. They're normal brain function, consciousness experiencing itself, creating worlds from pure neural activity. Perhaps the most memorable aspect of dreams is how they feel. You might forget dream plots, forget who was there or what happened, but you remember the feeling, the terror of a nightmare, the euphoria of flying, the sadness of loss, the confusion of being lost, the anxiety of being unprepared. Emotions are dreams' most persistent element, the part that stays with you longest after waking. This emotional intensity makes sense given the amygdala's activity during REM. The amygdala generates emotional responses, and it is working hard during dreams, creating emotions that flood the dream experience. These aren't muted emotions. They're often more intense than waking emotions, because you're not inhibiting them. While awake, your prefrontal cortex regulates emotional expression. In dreams with prefrontal cortex, quiet emotions run unchecked, reaching peaks of intensity that waking rarely allows. Dreams bias toward negative emotions more than positive. Studies of dream content find more fear, anxiety, sadness, confusion, and anger than joy, contentment, love, or excitement. This negativity bias might serve adaptive functions, preparing for threats, processing difficulties, practicing emotional regulation. Or it might simply reflect that your brain tags negative experiences as more significant, worthy of more processing, hence more likely to become dream content. But positive dreams definitely occur. Dreams of flying often feel exhilarating. Dreams about loved ones can feel loving and warm. Dreams where you succeed or achieve can feel triumphant. Sex dreams, which occur during REM despite the association with physical arousal, can feel pleasurable. Not all dreams are nightmares. Many are neutral or pleasant. The negative bias just means threatening or challenging dreams are somewhat more common. Emotional residue from dreams can affect waking mood. Wake from a nightmare, and you might feel anxious for minutes or hours. Wake from a pleasant dream, and you might carry that warmth into your day. Your brain doesn't immediately forget dream emotions when you wake. They linger, affecting your state. This suggests emotional processing during dreams has real effects, changing your emotional baseline, helping regulate how you feel. Sometimes dreams create novel emotional experiences, feelings you don't have names for, emotional states unique to dreaming. A sense of cosmic significance, profound knowing, ineffable unity, strange nostalgia for places you've never been. These are common dream feelings that don't translate well to waking language. They show consciousness can generate emotional states outside the normal waking range. Lucid dreamers often report that recognizing their dreaming changes dream emotions. Fear diminishes when you know it is just a dream. Some lucid dreamers deliberately seek positive experiences, flying for joy, exploring for curiosity, creating beautiful scenes for aesthetic pleasure. Lucidity allows emotional choice, using dreams intentionally for positive emotional experiences. Nightmares are emotional dreams taken to extreme fear and horror, so intense they wake you. We'll explore nightmares more later, but note here that they're not different in kind from other dreams, just more emotionally intense, exceeding the threshold where sleep can contain the experience. They're the emotional processing system working overtime, perhaps appropriately given life stress, perhaps overreacting. Tonight, your dreams will have emotional textures. Perhaps subtle mild interest, vague concern, perhaps intense real fear, genuine joy. Whatever emotions arise, they're your brain processing, your amygdala working, your emotional life being integrated and regulated through the medium of dreams. Feel them fully while dreaming, then let them go upon waking, knowing they've served their purpose. A nightmare is a dream that goes wrong, or perhaps goes too right. The emotional intensity becoming so strong, it breaks through sleep's boundary and wakes you. Your heart pounds, your breath comes fast, you are sweating or trembling. For a few moments, the nightmare feels more real than your bedroom. The fear persists even as you realize you are awake, safe, that none of it was actually happening. Nightmares are universal. Every culture has them, every person experiences them at least occasionally. Children have them more frequently than adults, perhaps 2 to 4 times per month for young children, once or twice per month for older children. Adults typically have fewer, maybe 1 nightmare per month on average, though this varies enormously. Some adults have nightmares weekly, others go years between nightmares. It is important to distinguish nightmares from night terrors. Night terrors occur during deep sleep, stage 3, not REM. Someone experiencing a night terror might scream, thrash, appear terrified, but they not actually awake and usually don't. Remember the episode. Night terrors are more common in children and tend to fade with age. They re-dramatic, but not the same phenomenon as nightmares, which are REM dreams with intensely negative emotional content. Nightmares happen during REM, usually later in the night when REM periods are longest. They re-dreams that trigger such intense fear or horror that the emotional response wakes you. Often you wake mid-dream, the narrative unresolved, the threat still present in your mind. This sudden waking from intense emotion creates that characteristic nightmare experience. Confusion, lingering fear, relief at realizing it wasn't real mixed with residual anxiety. What makes nightmares more common during certain periods? Stress is a major factor. When you are anxious, worried, dealing with difficulties, nightmares increase. Your brain is processing threat-related material, and sometimes that processing becomes intense enough to create nightmares. Illness can trigger nightmares. Fever affects brain function, altering dream content. Certain medications increase nightmare frequency, particularly those that affect neurotransmitters or REM sleep. Trauma leads to nightmares, sometimes recurring nightmares that replay traumatic events. But sometimes, nightmares occur without obvious triggers. Your brain generates a frightening scenario spontaneously, perhaps testing threat response systems, perhaps processing fears you are not consciously aware of, perhaps just because the random combination of memories and associations produced something scary. Not every nightmare has a clear cause or meaning. Having nightmares doesn't mean something is wrong with you. They are a normal part of dream life, an expected variation in REM experience. Most nightmares are isolated events, unpleasant, briefly disturbing, then forgotten. Only when nightmares become frequent enough to disrupt sleep quality or cause ongoing distress do they become a clinical concern. Occasional nightmares are just part of being human, part of having an active dreaming brain that sometimes generates content that is too intense to sleep through. Tonight, you probably have a nightmare. They are not that common, and the relaxed state you are entering tends to reduce nightmare frequency. But if you do, remember, it is temporary, it will end, and waking means safety. Nightmares are your brain working, sometimes working too intensely, but always working on your behalf, trying to process, trying to protect, trying to help even when the help feels harsh. Certain nightmare scenarios appear repeatedly across different people, different cultures, different time periods. Being chased is perhaps the most common nightmare theme, running from something threatening, unable to escape, the pursuer always behind you, sometimes catching you, just as you wait. The threat might be human, animal, monster, or something undefined, just presence and danger. You run but can't run fast enough, your legs heavy, movement difficult. The dream adding the frustration of impaired movement to the fear of pursuit. Being attacked is another frequent nightmare, physical assault, violence, pain. Sometimes you're fighting back, often you're helpless, unable to defend yourself effectively. The attacker might be known or unknown, human or creature. These nightmares often reflect feelings of vulnerability or powerlessness. In waking life, your brain translating emotional threats into physical danger. Falling nightmares involve losing control, plummeting from heights, ground giving way, falling endlessly through space. Sometimes you wake just before impact. The supposed danger of not waking, dying in a dream means dying in reality, is pure myth. These nightmares might relate to loss of control, instability, fear of failure. The sensation of falling is visceral, often accompanied by that stomach drop feeling that can jolt you awake. Witnessing harm to loved ones is particularly distressing, watching helplessly as family members or friends are hurt, threatened, killed, unable to intervene or save them. These nightmares are emotionally devastating, worse than threats to yourself, because they combine fear with helplessness and the agony of losing someone you love. They often reflect anxiety about loved one's safety or fear of loss. Natural disasters appear in nightmares: earthquakes, floods, fires, tornadoes. The world becoming hostile, safe places turning dangerous, environment itself threatening. These might reflect general anxiety about things beyond your control, or they might process actual experiences with natural disasters. Being trapped is a common nightmare scenario, locked in rooms, buried alive, caught in confined spaces, unable to escape. The walls close in, air runs out, panic builds. These claustrophobic nightmares often relate to feeling trapped in life situations, jobs, relationships, circumstances. You can't easily leave. Social nightmares involve exposure, humiliation, shame, being naked in public, failing publicly, everyone watching and judging. These feel different from threat nightmares, less about physical danger, more about social consequences, reputation damage, loss of dignity. They reflect anxieties about how others perceive you, fear of judgment or rejection. Recurring nightmare repeating often indicate unresolved issues. Your brain keeps returning to the same scenario, trying to process something that hasn't been successfully integrated. Recurring nightmares about actual past traumas are common in PTSD, but recurring nightmares can also be about fears or concerns that persist. Your brain repeatedly working on material it finds significant or troubling. Whatever nightmare content arises, remember it comes from your own mind. The scariest monsters in dreams are generated by your brain, which means they're subject to your brain's rules, constrained by your memories and imagination. Even the worst nightmares are still just dreams, powerful, affecting, sometimes traumatic feeling, but fundamentally different from waking reality in their ephemerality. This might sound strange when you're in the grip of nightmare fear, but nightmares might serve beneficial functions. They're unpleasant, yes, but unpleasant experiences can be adaptive, like how pain protects you from damage by making you avoid harmful things. Nightmares might protect or prepare you psychologically. The threat simulation theory applies especially to nightmares. If dreams simulate threats to practice responses, Nightmares are intensive training boot camp for your threat response systems. By generating intensely frightening scenarios, your brain tests your reactions under pressure. Can you think clearly when terrified? Can you take action despite fear? Do you freeze, fight, or flee? Nightmares provide data about your stress responses, keeping these systems active and calibrated. For trauma survivors, nightmares are complicated. PTSD nightmares often replay traumatic events, the same scenarios recurring, sometimes exact repetitions, sometimes variations on the theme. This can feel like torture, like your brain is attacking you. But there is a theory contested, but worth considering, that these nightmares represent attempts at processing. Your brain is trying to integrate the trauma, make sense of it, file it away as past rather than present threat. Sometimes this processing gets stuck, repeating without progress, which is part of PTSD's pathology. But the attempt itself might be adaptive, the system trying to heal even when it is not succeeding. Some therapies work directly with nightmares. Imagery rehearsal therapy has trauma survivors write down nightmares, then consciously rewrite them with different, less threatening outcomes. They rehearse these new versions while awake. Often, nightmares decrease after this practice, suggesting the brain can be influenced, can update its threat simulations, can learn new responses. This therapeutic success suggests nightmares are modifiable processes, not just random suffering. Nightmares also might serve emotional regulation by allowing intense fear in a safe context. You experience terror, your body responds with stress hormones and racing heart, but you're actually lying safe in bed. You get to feel extreme emotion without real danger. This might desensitize you slightly, might build emotional resilience, might help you understand that feeling fear doesn't mean you're actually in danger. It is exposure therapy administered by your own brain. Some researchers suggest nightmares are the cost of having an active threat detection system. Better to have occasional false alarms, nightmares, than to miss real threats. Your brain errs on the side of caution, generating threatening scenarios liberally, accepting that most will be false positives if it means catching actual dangers. From this view, nightmares are the price of vigilance. Culturally, nightmares have often been seen as meaningful warnings, messages, spiritual communications. Modern psychology mostly doesn't support supernatural interpretations, but the sense that nightmares mean something persists. Maybe they do mean something, not prophecy or external messages, but internal ones. They show what you fear, what you're processing, what concerns occupy your threat detection systems. They're revealing, even if not in the ways traditional interpretation suggested. None of this makes nightmares pleasant. Even if they serve functions, they're still distressing. But knowing they might be purposeful, might be your brain working rather than malfunctioning, might offer some comfort. Nightmares aren't punishments or signs of weakness. They're part of the emotional and cognitive processes that keep you functioning, adapted, aware of threats real and imagined. Sometimes the boundaries between sleep and waking blur in particularly frightening ways. Sleep paralysis is one such experience. Waking while your body remains in REM atonia, unable to move, feeling trapped in your own immobile body. This alone is terrifying. But sleep paralysis usually comes with additional disturbing features. Many people experiencing sleep paralysis sense a presence in the room. Something or someone is there, watching, threatening. They can't see it clearly, though sometimes they can, but they feel it, menacing, close. This present sensation is so common across cultures that every culture has developed explanations: demons, spirits, aliens, the old hag in Newfoundland folklore, the shadow people in various traditions, djinn in Islamic cultures, alien abductors in modern Western contexts. These are all cultural interpretations of the same neurological phenomenon. Often there is a pressure on the chest, a weight, something sitting or pressing on you, making breathing difficult. Combined with paralysis and the present sensation, this creates overwhelming fear. You're awake, aware, but can't move, can't breathe easily, and something threatening is in the room with you. It is one of the most terrifying experiences humans can have, and it is entirely generated by the brain's state between REM and waking. What causes sleep paralysis? It is REM atonia, persisting into partial wakefulness. Your consciousness has returned enough to be aware to open your eyes to try to move, but the paralysis mechanism hasn't released yet. You're caught in a hybrid state, awake enough to perceive your environment, asleep enough that REM features, paralysis, dream-like hallucinations persist. The present sensation likely comes from threat detection systems activated by the unusual situation. Your brain recognizes something is wrong. You're conscious but can't move, which never happens normally, and interprets this as potential danger. Threat detection activates, creating the sense that something threatening must be present. Your amygdala is still partially in REM mode, generating fear, and your consciousness confabulates an explanation. Something is here, that is why you can't move, that is why you're afraid. The chest pressure is real, but not from external weight. It is your awareness of breathing during REM atonia. During REM, breathing is controlled by automatic systems, voluntary control is reduced. When you're conscious and trying to breathe voluntarily, but can't fully control your diaphragm, it feels restricted, difficult, like something is pressing on your chest. The sensation is real. The cause is neurological, not physical. Hypnagogic hallucinations occur while falling asleep. Hypnopompic hallucinations occur while waking. These are brief dream-like experiences at the threshold, seeing figures, hearing voices, feeling touches, sensing presences. They're your brain in a state between waking and sleeping, generating dream content while you're partially conscious. Usually they're brief and don't cause distress, but they can be vivid and startling. Sleep paralysis often combines with hypnopompic hallucinations. You're paralyzed, afraid, and you're also having vivid hallucinations. Shadowy figures in corners, demons approaching, aliens in the room. Your visual cortex is still partly in dream mode, generating imagery. These hallucinations feel completely real because they're generated by the same brain systems that process actual visual input. Understanding sleep paralysis doesn't make it less frightening in the moment, but knowing what it is helps afterward. If you experience it, remember you're safe. It will end, usually within seconds or minutes. You're not in danger. Nothing is actually there. Try to stay calm, focus on breathing. Move small parts if possible, fingers, toes, or just wait. It always ends. Paralysis always releases. And once it does, you're back to normal waking consciousness. Nightmares are part of dreaming, and dreaming is part of being human. You can't eliminate nightmares entirely without eliminating dreams, which would require eliminating REM sleep, which would cause serious problems. So the question isn't how to never have nightmares, but how to relate to them when they occur, how to minimize their frequency and impact, how to recover quickly and return to restful sleep. First, recognize nightmares as dreams, not reality. This seems obvious while awake, but becomes important in the confused moments after waking from a nightmare. You're disoriented, the nightmare still vivid, emotions still intense. Ground yourself quickly, turn on lights, look at familiar objects, remind yourself where and when you are. I'm in my bedroom. It is tea time. That was a dream. I'm safe now. Simple, clear, repeated if necessary. This helps your brain shift from dream state to waking state, from threat response to calm. Writing nightmares down can help. Keep paper and pen by your bed, or use your phone. When you wake from a nightmare, write it down. Not to analyze it necessarily, but to externalize it. Getting the content out of your head and onto paper creates distance. You're observing the nightmare rather than being immersed in it. You're the writer, not the victim. This simple shift in perspective can reduce emotional impact. Imagery rehearsal therapy can be done informally. Take your written nightmare and rewrite it with a different ending, one where you're more powerful, where the threat diminishes, where you're safe or victorious. This isn't denying the nightmare happened. It is creating an alternative version. Read your new version before sleep next night. Your brain might incorporate this version, might modify future nightmares, might reduce their intensity. Not always, but often enough to be worth trying. Some nightmares don't need intervention. They're isolated. You recover quickly. You go back to sleep without much trouble. These are just normal dream variation, like occasional bad weather. Accept them as part of dream life. Don't overthink them. Let them go. Not every nightmare requires analysis or action. But if nightmares become frequent, persistently disturb sleep, cause ongoing distress, consider seeking help. Cognitive behavioral therapy can address anxiety that might be fueling nightmares. Trauma-focused therapy helps process traumatic experiences that generate recurring nightmares. Sleep specialists can address sleep disorders that might increase nightmare frequency. Frequent nightmares aren't something you have to just endure. Help is available. For tonight, as you drift towards sleep, know that nightmares are unlikely. Most nights are nightmare-free. Your brain will probably cycle through REM periods peacefully, generating dreams that range from mundane to pleasant to strange, but not frightening. If a nightmare does occur, you'll wake from it, you'll recognize it as a dream, you'll ground yourself, and you'll be fine. Nightmares are temporary. They end. Sleep continues. Morning comes. You're safe right now in this moment. In your bed, breathing, relaxed. The night ahead holds sleep and dreams, most of which will be harmless, many of which you won't remember. Your brain will do its work while you rest, processing and consolidating. Sometimes creating vivid experiences, usually creating nothing you'll recall. Trust this process. Trust your brain, trust sleep. Nightmares, if they come, are just your brain working intensely uncomfortable, but ultimately harmless, passing like storms, leaving you safe on the other side. Imagine this. You are in a dream, perhaps flying through the sky or walking through an impossible city, and suddenly, mid-dream, you realize, this is a dream. You become aware that you are asleep, that this experience is generated by your own mind, that none of it is physically real. But instead of waking, you remain in the dream, now conscious within it. You are lucid dreaming. Lucid dreaming is that moment when awareness enters the dream state. You are asleep, in REM, your body paralyzed, your brain cycling through dream content, but you are conscious in a way you are normally not in dreams. You know you are dreaming. You recognize the dream as a dream while it continues unfolding. This awareness doesn't necessarily give you control, but it changes the experience fundamentally. You are no longer just experiencing the dream. You are aware that you are experiencing it. For some people, lucidity comes suddenly. A flash of recognition. I am dreaming. For others, it builds gradually, noticing something odd, questioning whether you are awake, testing reality, maybe trying to push a finger through your palm, seeing if physics works normally, slowly realizing this must be a dream. For a few people, lucidity is spontaneous and frequent. They know they're redreaming almost every time they dream, though most people need to cultivate lucidity deliberately. Studies suggest about 55% of people have experienced at least one lucid dream in their lifetime. About 23% of people have lucid dreams at least once, per month. Frequent lucid dreamers, those who have them weekly or more, are rarer, perhaps 5 to 10% of the population. Some people naturally lucid dream without effort. Others never experience it despite trying. Most fall somewhere in between, capable of lucid dreaming occasionally, especially if they practice techniques. The experience of lucidity varies widely. Sometimes it is brief. You realize you are dreaming, feel excitement at the realization, and immediately wake from the excitement. Other times, lucidity is stable and extended, lasting through long, complex dream adventures. You might explore dream landscapes, fly intentionally, create objects or scenes through will, engage with dream characters knowing they reconstructions of your mind. Lucidity doesn't necessarily mean control. You might know you are dreaming, but still be swept along by dream logic, unable to change the scenario. Or you might have substantial control, able to manipulate dream content, conjure whatever you wish, direct the dream narrative. Control seems to improve with practice. Experienced lucid dreamers report more ability to shape dreams than novice lucid dreamers. What makes lucid dreaming possible? It requires partial reactivation of the prefrontal cortex, specifically the dorsolateral prefrontal cortex, associated with self-awareness and metacognition. Normally, during REM, this region is quiet, which is why you don't question dream impossibilities. In lucid dreams, it activates just enough to provide self-reflective awareness. I am dreaming without waking you. You are in a hybrid brain state. REM characteristics, vivid imagery, emotional activation, narrative generation, plus waking, level self-awareness. Brain imaging studies have confirmed this. When people signal that they become lucid using pre-arranged eye movements, brain scans show increased frontal activity compared to non-lucid REM. The brain is reconfiguring mid-dream, bringing online the very region that allows you to know yourself, to think about your thinking, to recognize your state, as a dream state. Once lucid, many dreamers test the boundaries of what is possible. Flying is among the most common and popular lucid dream activities. While non-lucidly dreaming about flying, you might fly simply because the dream contains flying. But while lucidly dreaming, you can choose to fly, launch yourself into dream air intentionally, soar over landscapes, experience the sensation of flight with full awareness that you're doing it. Lucid dreamers describe flying as exhilarating, liberating, one of the great joys of lucid dreaming. You can explore dream environments with curiosity and intention. Walk through cities that don't exist, enter buildings, and see what your mind has constructed inside. Examine details you'd normally overlook. Many lucid dreamers are fascinated by what their unconscious creates: the architecture, the people, the surprising details that appear when you look closely. It is touring your own psyche, seeing what imagination generates without conscious direction. You can interact with dream characters in new ways. Knowing their dream generated, you might ask them questions. Who are you? What do you represent? What should I know? Sometimes dream characters provide surprising answers, insights that feel meaningful. Sometimes they refuse to acknowledge their dream constructs, insisting they're real. Sometimes they simply dissolve or transform when questioned. Dream characters are unpredictable, but lucid awareness allows experimental interaction, treating them as aspects of yourself, asking what they might reveal. Some lucid dreamers use dreams for skill practice. Musicians practice their instruments in lucid dreams. Athletes rehearse movements, run simulations of competitions. While the physical practice benefits are debated, you can't build muscle while paralyzed and sleeping. Mental practice definitely occurs. Your motor cortex is active. You're simulating the movements neurologically, which contributes to skill development. Studies show mental practice works. Lucid dreams might be an extended mental practice environment. Creative problem-solving happens in lucid dreams. Artists might create dream paintings or sculptures, examining them from all angles, playing with dream physics to create impossible art. Writers might compose stories or poems. Scientists might visualize abstract concepts, exploring theories in dream space where visualization can become literal. Lucidity provides a virtual reality playground for any mental activity. Confronting fears is another use. If you're afraid of heights, you might deliberately dream of high places while lucid. Knowing you're safe, using the dream to practice being at heights without real danger. If you have recurring nightmares, lucidity allows you to rewrite them mid-dream, transforming the monster, flying away from the threat, confronting it with awareness that it can't truly harm you. This exposure therapy within dreams has therapeutic potential. Some lucid dreamers explore consciousness itself. They meditate within dreams, examine the nature of awareness, test the boundaries between waking and sleeping consciousness. These explorations often feel profound insights about mind, self, reality that persist after waking. Whether these insights are genuine or just feel that way is debatable, but the experience is meaningful to the dreamers. Control varies. Some lucid dreamers have substantial agency. They decide where to go, what to do, what appears in the dream. Others have awareness, but little control. They know they're dreaming but can't change much, still mostly following the dream's momentum. Most fall in between, able to influence the dream but not dictate it completely, collaborating with the unconscious rather than commanding it. Tonight, if you're curious about lucid dreaming, you might simply hold the intention. If I dream, I'll recognize I'm dreaming. Don't force it, don't create pressure, but let the possibility exist. Lucidity often happens spontaneously, especially when you're aware it is possible, when you're curious about it, when you invite it without demanding it. When researchers study lucid dreamers in sleep labs, they see something fascinating: a brain that is both asleep and awake in different ways simultaneously. The EEG shows REM patterns, fast, irregular waves, indicating the person is definitely in REM sleep. Their body is paralyzed, REM atonia verified by lack of muscle tone. By standard measures, they re-sleeping. Yet they can signal researchers through eye movements, following pre-arranged patterns, confirming they reconsciously aware and responding to instructions while asleep. This communication breakthrough came in the late 1970s when researcher Stephen Labage trained himself to lucid dream, then signaled researchers from inside dreams. He moved his eyes and agreed. Upon sequences, left-right, left-right. For instance, while dreaming lucidly, researchers watching EEG saw REM sleep confirmed paralysis, recorded the eye signals. This proved conclusively that consciousness could exist during REM, that people could be aware while dreaming, that the boundary between sleeping and waking consciousness was more permeable than previously thought. Brain imaging reveals what makes lucidity possible. fMRI studies show that during lucid REM, the dorsolateral prefrontal cortex, DLPFC, becomes more active than during non-lucid REM. This region is associated with executive function, self-awareness, working memory, precisely the capacities needed to recognize you are dreaming and maintain that awareness. In regular REM, DLPFC is relatively quiet. In lucid REM, it partially reactivates. Interestingly, the DLPFC doesn't reactivate to waking levels. That would wake you. It reactivates just enough to provide metacognitive awareness, awareness of your own awareness, while leaving other REM features intact. You remain in REM. Your visual cortex is generating imagery. Your amygdala is active emotionally. Your body is paralyzed. But you've added a layer of self, reflective consciousness, typically absent from dreams. Other brain regions also show altered activity during lucid REM. The temporoparietal junction, involved in self, other distinction and spatial awareness, activates more in lucid dreams. The precuneus, part of the brain's default mode network associated with self, referential thought, shows increased activity. These regions together create the phenomenology of lucidity, knowing yourself, knowing your state, maintaining perspective on the dream while remaining within it. Neurotransmitter balance affects lucidity. Acetylcholine is high during REM, supporting vivid dreams. Acetylcholinesterase inhibitors, which increase acetylcholine, can increase lucid dream frequency. Some supplements that affect neurotransmitters, like galantamine, have been studied for lucidity induction, showing modest but real effects. This suggests lucidity is just about training, but also about brain chemistry, about getting the right neurochemical mix to support hybrid consciousness. Lucid dreaming might provide unique insights into consciousness. It shows that being aware and being awake aren't identical. You can be conscious without being awake. Consciousness has multiple configurations. This challenges simple models of consciousness, as on he-off, awake, asleep. Instead, consciousness appears more like a spectrum or multidimensional space, with lucid dreaming occupying a region that is neither fully waking nor fully dreaming, but distinctly its own state. Some researchers study lucid dreaming as a model for understanding consciousness more broadly. If we can identify what neural changes create self-awareness in dreams, we might understand what creates self-awareness generally. Lucidity becomes a laboratory for consciousness research, a naturally occurring altered state that is accessible, controllable, and illuminating. For you, the neuroscience matters less than the experience. Whether you lucid dream or not, your brain is capable of these different configurations. Your consciousness is more flexible than you might realize. And that flexibility, moving between waking, sleeping, dreaming, lucid dreaming, and all the states in between, is part of what makes consciousness so fascinating, so rich, so worth paying attention to. Many people want to experience lucid dreaming, attracted by its potential for adventure, creativity, or self-exploration. Numerous techniques exist for inducing lucidity, ranging from simple to complex, from validated by research to purely anecdotal. Here are some approaches presented without pressure. Remember, lucid dreaming isn't necessary for good sleep or meaningful dreams. It is simply one interesting possibility among many. Reality testing is perhaps the most common technique. Throughout your day, regularly question whether you are awake or dreaming. Look at your hands. Do they look normal? Try to push a finger through your palm. Does it pass through dreaming or stop waking? Look at text. Look away. Look back. Does it stay the same waking or change dreaming? Jump. Do you float dreaming? Or land normally waking? These tests establish a habit of questioning reality. When this habit transfers into dreams, you might test reality mid-dream, discover you are dreaming, and become lucid. Dream journals help by improving dream recall and recognition. Keep a journal by your bed immediately upon waking. Write down any dreams you remember. Over time, you'll remember dreams more frequently and clearly. You'll also start recognizing dream patterns, themes that recur, oddities that appear across multiple dreams. This familiarity with your dream content makes it easier to recognize when you are dreaming, which can trigger lucidity. Mnemonic induction of lucid dreams. Mild involves setting an intention as you fall asleep. Repeat to yourself, "Next time I am dreaming, I'll remember I am dreaming." Visualize yourself becoming lucid in a recent dream, replaying the dream, but adding the moment of recognition. Hold this intention gently without strain as you drift towards sleep. The technique essentially programs your mind to recognize dreams, priming for lucidity. Wake, back, to, bed. WBTB combines with other techniques for stronger effect. Set an alarm for 5 to 6 hours after falling asleep. When REM periods are longest, wake briefly. Stay awake for 20 to 30 minutes, doing something engaging but not arousing, reading about lucid dreaming, practicing mild, then return to sleep. You are more likely to enter REM quickly and potentially with greater awareness, increasing lucidity chances. External cues can induce lucidity. Some people use devices or apps that detect REM through movement patterns and provide cues, flashing lights, sounds, vibrations, designed to be noticed in the dream without waking you. The cue becomes part of your dream, and if you've trained yourself to recognize it as a lucidity cue, you might become lucid. Effectiveness varies. Some find them helpful, others find they just wake them or don't appear in dreams. But here is the important part. Don't try to lucid dream tonight. Don't try to anything tonight. Effort works against sleep. Any technique that requires striving, monitoring, staying vigilant, these impede sleep onset and quality. Lucid dreaming happens best when you are relaxed, when intention is set gently without force, when you let go rather than trying hard. If lucidity interests you, experiment with techniques during the day or in other sleep periods. But for now, let go of goals and techniques. If lucidity happens spontaneously, wonderful. If it doesn't, equally wonderful. Sleep is what matters right now. Dreams will come, lucid or not, memorable or not, interesting or not. All of it is fine. All of it is your brain doing what it does, creating experiences, processing, exploring, existing in that mysterious state we call dreaming. Lucid dreaming reveals something profound about consciousness. It is modular and flexible. You can be asleep and awake simultaneously in different respects. Your body can be paralyzed while your mind is alert. Your prefrontal cortex can be partially active while other brain regions remain in REM configuration. Consciousness isn't a simple binary on or off, awake or asleep, but a complex system with many parameters that can vary independently. This modularity suggests consciousness is more like an orchestra than a single instrument. Different brain regions contribute different elements: vision, emotion, self-awareness, memory, logic, attention. In waking consciousness, all sections play together in one configuration. In sleeping consciousness, some sections go quiet. In lucid dreaming, the orchestra reconfigures again, most sections still playing the REM composition, but the self-awareness section rejoining mid-performance. The result is a unique sound, a unique state of consciousness. Lucid dreaming also reveals that the boundary between voluntary and involuntary is permeable. In waking life, you generally control your actions, voluntary, but not your perceptions, involuntary. You see what is there, not what you wish. In regular dreams, both are involuntary. You don't control dream actions or dream perceptions. You just experience whatever unfolds. In lucid dreams, you can gain some voluntary control over what is normally involuntary. You can decide to fly, and you fly. You can decide a door leads somewhere specific, and it does. The dream responds to intention in ways reality doesn't. This shows imagination's power within consciousness. When external reality isn't constraining perception, intention can shape experience directly. Lucid dreams are pure imagination, made experiential, thoughts becoming sights, intentions becoming events. This isn't magic, It is just consciousness operating in a mode where internal generation isn't corrected by external input, but it feels magical, feels like creative power unleashed. Philosophically, lucid dreams raise questions about reality and illusion. If a dream can feel completely real until you recognize it is a dream, how do you know waking life isn't also a dream you haven't recognized yet? This is the ancient philosophical problem of skepticism, and lucid dreaming makes it visceral. You've experienced being absolutely convinced of reality, only to discover you were dreaming. Could the same be true of waking? Probably not. Waking life has consistencies dreams lack, but lucid dreaming makes the question emotionally real, not just intellectually abstract. Some spiritual traditions use lucid dreaming as practice for liberation or enlightenment. Tibetan Buddhism developed dream yoga, using lucidity to recognize all experience, waking and sleeping, as illusory or empty of inherent existence. If you can wake up within a dream, maybe you can wake up within waking life, achieving enlightenment. Whether this works metaphysically or not, it is psychologically interesting, using lucidity as training in metacognitive awareness, learning to witness experience with perspective. For most people, lucid dreaming is simply fascinating, rather than spiritually transformative. It is a unique state of consciousness, enjoyable and interesting to explore, revealing about how minds work. Whether you ever lucid dream or not, knowing it is possible changes something about how you view consciousness. You're capable of configurations you rarely experience. Your brain can reconfigure on the fly. Awareness is more flexible than daily life suggests. Tonight, you'll probably dream without lucidity, and that is perfect. Regular dreams have their own value, their own work to do. But somewhere in your mind, the capacity for lucidity exists, waiting. Maybe someday you'll access it spontaneously, find yourself aware within a dream, realize you're in that fascinating hybrid state. And maybe you won't, and you'll live a rich dream life anyway, experiencing the nightly theater without metacognitive awareness. Both are valid. Both are part of the range of human consciousness, the extraordinary flexibility of your dreaming, sleeping, waking brain. Before science, before neurology, before understanding of brain function, humans knew dreams were important. They devoted enormous attention to dreams, developed elaborate systems for understanding them, built institutions around dream interpretation. This wasn't ignorance or superstition. It was a different way of knowing, a different framework for making sense of consciousness and nightly visions. Ancient Egypt revered dreams as messages from gods. The Chester Beatty Papyrus, dating to around 1350 BCE, lists dreams and their interpretations. Dreams of drinking warm beer, bad. Dreams of seeing oneself in a mirror, bad, predicts another wife. Apparently, dreams of climbing a mast, good, seeing one, sad. These interpretations seem arbitrary now, but they show how systematically Egyptians approached dreams, treating them as readable texts requiring expert decoding. Egyptian temples included dream incubation chambers, special rooms where people slept hoping to receive divine dreams. Priests facilitated this process, performing rituals, providing sacred spaces, interpreting resulting dreams. Important decisions, personal and political, were influenced by dreams received in these sacred contexts. Dreams were taken as seriously as any other form of knowledge, perhaps more seriously. Greece and Rome adopted similar practices. Temples of Asclepius, the god of healing, hosted supplicants who slept overnight, seeking healing dreams. The process was elaborate: purification, sacrifice, sleeping in the temple, esabaton, sacred bedroom, waiting for Asclepius to appear in dreams and cure illness or provide treatment instructions. Testimonials suggest many experienced dramatic healings after temple dreams. Whether these were psychosomatic, placebo effects, or something else, people believed in and benefited from dream incubation. The Bible is filled with significant dreams. Jacob dreams of a ladder, reaching heaven with angels ascending and descending. A theophany, direct divine communication. Joseph interprets Pharaoh's dreams, predicting famine, enabling Egypt to prepare. Daniel interprets Nebuchadnezzar's dreams, demonstrating prophetic power. Throughout biblical narrative, dreams are vehicles for divine messages, warnings, prophecies. Ignoring dreams means ignoring God's communication. Mesopotamian cultures produced extensive dream interpretation literature. The Epic of Gilgamesh includes dream sequences where gods communicate with heroes. King Ashurbanipal kept dream diaries, recording his dreams as historical documents. Dreams foretold military outcomes, legitimized rule, warned of dangers. In polytheistic contexts, different gods sent different dreams, each requiring proper interpretation to understand which deity was communicating. These ancient peoples weren't primitive in their dream attention. They were sophisticated, just operating in different paradigms. Without understanding neurochemistry, they attributed dreams to external sources, gods, spirits, the divine realm. This made sense given their worldview, and maybe something true persists in their approach. Dreams do feel like they come from elsewhere, from beyond conscious control. The externalization might be metaphorically accurate, even if not literally true. Ancient humans also recognized dreams' therapeutic and creative potential. Poets credited dreams for inspiration. Healers sought diagnostic dreams. Leaders consulted dream interpreters before major decisions. They knew experientially what modern research confirms: dreams matter, dreams contain useful information, dreams deserve attention. As you drift towards sleep tonight, you are joining this ancient human practice. For thousands of years, billions of people have closed their eyes, entered sleep, visited dream realms. You are part of that unbroken chain, that universal human experience. The context has changed. You understand REM sleep, neurotransmitters, brain regions. But the essential experience remains consciousness, transforming. New worlds appearing. Indigenous cultures worldwide developed sophisticated dream practices, often more complex and central to their spiritual lives than ancient Mediterranean cultures. For many indigenous peoples, dreams weren't just important, they were primary reality, more real than waking life, the realm where truth was revealed and power obtained. Many Native American traditions practiced vision quests, deliberate seeking of transformative dreams or visions, often through fasting, isolation, prayer, and extended wakefulness. Young people at transitions, puberty, coming of age, might spend days alone in wilderness, seeking a vision dream that would provide life direction, reveal their name, connect them with spirit guides. These weren't ordinary dreams but sought after, life-defining spiritual experiences facilitated by dreams' capacity for profound consciousness shifts. Different tribes had different dream beliefs. Some saw dreams as soul journeys, your soul leaving your body at night, traveling to other realms, encountering spirits, ancestors, other souls. Waking recalled these journeys. Some emphasized dream incubation, sleeping in sacred places or with sacred objects to invite particular dreams. Some practiced collective dreaming, gathering to share and interpret dreams communally, treating dreams as information relevant to the whole community, not just the individual. The Senui people of Malaysia, according to anthropologist Kilton Stewart's possibly romanticized accounts, supposedly practiced systematic dream control, teaching children to confront dream threats, befriend dream enemies, continue pleasant dreams to resolution. Whether this was accurate ethnography or Stewart's invention is debated, but it influenced Western interest in lucid dreaming and dream control, showing how indigenous practices affected modern approaches. Australian Aboriginal cultures speak of the dreamtime, or dreaming, a complex concept referring to both a mythological past when ancestral beings created the world and an eternal present accessible through dreams, ritual, and sacred sites. The dreaming isn't just history, it is ongoing reality, more fundamental than ordinary time and space. Dreams connect individuals to this deeper reality, allow communication with ancestors, facilitate understanding of the world's sacred structures. Amazonian shamanic traditions use ayahuasca and other plant medicines to induce visionary dreams or dreamlike states. These aren't considered mere hallucinations but genuine voyages to spiritual realms, meetings with plant spirits and entities, sources of healing knowledge and cosmic understanding. The boundary between waking visions and sleeping dreams blurs. Both are altered states providing access to ordinarily hidden dimensions of reality. Indigenous dream practices often include communal elements. Dreams are shared in morning gatherings, discussed, interpreted collectively. Dream symbols are culturally shared rather than purely personal, a particular animal appearing in dreams has agreed upon meanings within the community. This creates collective dream language, shared symbolic vocabulary that enables communication through dreams about matters of tribal importance. Many traditions emphasize dreams as prophetic or precognitive, revealing future events, warning of dangers, guiding decisions. Western science is skeptical of literal precognition, but indigenous peoples report countless instances of accurate dream premonitions. Whether these are coincidence, selective memory, or something science doesn't yet understand remains debated. But the conviction that dreams provide real information about real future events is widespread across indigenous cultures. What is striking is how seriously these cultures take dreams, how central dreams are to their worldviews, how much attention and practice they devote to dreaming. They've developed expertise in consciousness, modulation, dream recall, dream interpretation that many modern people have lost. Indigenous wisdom about dreams, though expressed in different frameworks than neuroscience, might contain insights worth recovering, ways of relating to dreams that honor their significance without requiring scientific validation. Eastern philosophical and religious traditions have developed sophisticated understandings of dreams, often integrating them into larger frameworks about consciousness, reality, and enlightenment. Rather than seeing dreams as messages from external sources, Eastern philosophies tend to see them as revealing consciousness itself, showing how mind creates experience. Buddhism addresses dreams in several ways. One teaching, dreams are illusions, but so is waking life. Both are impermanent, constructed, lacking inherent existence. The difference between dreaming and waking is less significant than Western thought assumes. Both are mental phenomena. Both arise from causes and conditions. Both are empty of inherent reality. Recognizing dreams as illusory helps practitioners recognize waking life's illusory nature, advancing toward enlightenment. Tibetan Buddhism specifically developed dream yoga practices for maintaining awareness through dreams, using sleep as meditation training. The goal isn't just lucid dreaming, though that is part of it, but recognizing the dream as dream, the waking as waking, and both as manifestations of mind. Advanced practitioners supposedly maintain continuous awareness through sleeping, dreaming, waking, never losing the thread of consciousness, witnessing all states with equanimity. The Tibetan Book of the Dead describes bardos, intermediate states between death and rebirth. Dream bardo, the dream state parallels death bardo. Practicing awareness in dreams prepares for awareness during death, potentially affecting rebirth or achieving liberation. This elevates dream practice to existential significance. What you do in dreams matters for your ultimate fate. Hinduism's Mandukya Upanishad describes 4 states of consciousness: waking Jagrat, dreaming Svapna, deep sleep, Sushupti, and pure consciousness, Turiya. Dreaming is one of 3 ordinary states, distinct from waking but equally valid as consciousness configuration. The goal is realizing Turiya, consciousness that underlies all 3 states, witnessing all without being any of them. Dreams are stepping stones toward understanding consciousness's fundamental nature. Hindu philosophy suggests that just as you create your dreams, all characters, all environments, all events generated by your own mind, so too might universal consciousness, Brahman, create waking reality. The world is Brahman's dream. Individual consciousness is Brahman temporarily forgetting itself, lost in the dream of separate existence. Waking from this cosmic dream is enlightenment, recognizing you're not the separate self, but Brahman itself. These philosophies use dreams as teaching tools about consciousness and reality. Dreams demonstrate that consciousness can create entire convincing worlds, that experience doesn't require external reality, that what seems solid and real can be revealed as mental construction. If dreams can do this, what about waking life? Maybe it too is constructed. Maybe apparent solidity is illusion. Maybe consciousness is more fundamental than matter. Meditation practices in these traditions often include attention to dreams. Practitioners are instructed to maintain awareness through sleep, to watch dreams without identifying with them, to recognize dream content as mind-created. This builds metacognitive capacity, awareness of awareness, witnessing consciousness that sees all experience as arising and passing within it. Some Eastern teachers suggest that enlightenment is like waking from a dream, suddenly recognizing that what seemed real was mental construction, that suffering arose from identifying with illusory self, that liberation is simply seeing through the illusion. Dreams become metaphor for spiritual awakening. Just as you wake from dreams into greater clarity, you can wake from conventional consciousness into enlightened awareness. Whether these philosophical claims are literally true matters, less than their psychological and phenomenological insights. Dreams do show consciousness creating experience. They do demonstrate that apparent reality can be questioned. They do provide opportunities for metacognitive awareness. Eastern traditions have explored these insights deeply, developing practices and philosophies that illuminate dreams' significance beyond individual psychology, positioning them as keys to understanding existence itself. Western psychology's modern engagement with dreams began with Sigmund Freud's The Interpretation of Dreams, 1900. Freud called dreams the royal road to the unconscious, suggesting they revealed repressed wishes, hidden desires, conflicts too uncomfortable for conscious awareness. Dreams disguised these wishes through symbols, manifest content, what you remember, concealed latent content, underlying meaning. Interpretation required decoding, uncovering what dreams really meant beneath their symbolic disguise. Freud's approach assumed dreams were meaningful, worthy of sustained attention, revelatory of inner life. This was revolutionary in scientific context, bringing subjective experience into psychological study, treating dreams as data rather than dismissing them as meaningless neural noise. Freud's specific interpretations are mostly rejected now. His sexual symbolism, Oedipal complexes, rigid symbol meanings. But his core insight persists. Dreams matter psychologically, deserve investigation, reveal something about the dreamer. Carl Jung broke with Freud over dream interpretation. Jung saw dreams not as disguises, but as direct expressions of the unconscious, using symbolic language. Dreams didn't hide meaning, they spoke truth in symbols because symbols were the unconscious's natural language. Rather than universal symbol meanings, Jung emphasized personal associations. What does this symbol mean to you, in your life context, given your experiences? Jung introduced the concept of archetypes, universal patterns in the collective unconscious appearing in dreams across cultures. The hero, the shadow, the anima-animus, the wise old man. These figures appear in individual dreams, but carry transpersonal significance, connecting dreamers to humanity, a shared psychological inheritance. Dreams weren't just personal, but also mythological, tapping into structures deeper and older than individual psyche. Jungian analysis emphasizes dream series rather than single dreams. Patterns across multiple dreams reveal psychological processes unfolding over time, recurring symbols, evolving themes, transformation of dream elements. All show the psyche working toward integration, individuation, wholeness. Dreams become maps of psychological development, showing where you are in life's journey. Later psychologists developed other approaches. Fritz Perls and Gestalt therapy suggested every dream element represents aspects of yourself, even objects and settings. By role-playing different elements, you recover projected aspects, integrate split-off parts. Calvin Hall pioneered quantitative dream content analysis, cataloging themes statistically, showing patterns across populations. Rosalind Cartwright studied dreams, role in mood regulation and problem solving, emphasizing adaptive functions over symbolic meaning. Contemporary psychology is less focused on universal interpretations, more on personal meaning and neurocognitive function. Dreams are seen as combining memory consolidation, emotional processing, threat simulation, and random neural activity, multiple functions simultaneously, no single purpose or meaning. Interpretation becomes personal rather than expert-driven. What does this dream mean to you? How does it feel? What does it suggest about your current concerns? This democratization of dream interpretation respects individual experience without requiring specialized knowledge. You are the expert on your dreams because they yours, created by your brain from your memories and concern. External interpretations, Freudian, Jungian, any system, are just frameworks, potentially useful, but not authoritative. Your felt sense of what dreams mean matters most. Western psychology has thus moved from seeing dreams as coded messages requiring expert decoding, to seeing them as direct expressions requiring personal reflection, to seeing them as multifunctional processes that might have personal meaning or might just be neural housekeeping. All approaches agree dreams are worth attending to, though they disagree on why and how to interpret them. Every individual develops their own relationship with dreams, their own dream culture. Some people remember dreams nightly, keep detailed journals, analyze patterns, find recurring themes, work consciously with dream content. For them, dreams are significant, a rich inner life deserving attention and respect. They might use dreams for problem-solving, creative inspiration, self-understanding, or spiritual development. Dreams are valued, cultivated, integrated into waking life. Others rarely remember dreams, don't prioritize them, see them as interesting curiosities, but not particularly meaningful. Their dream culture is minimal. Dreams happen, might be briefly noted, then forgotten. Sleep's purpose is rest, not dream exploration. Dreams are acknowledged but not emphasized. This approach is equally valid. Not everyone needs to focus on dreams to live well. Some people fall between these extremes. They remember some dreams, find some meaningful. They might keep occasional dream notes without systematic journaling. They're open to dreams providing insights, but don't expect or demand meaning from every dream. This flexible, middle ground approach allows dreams to matter when they do without creating pressure to attend to every dream. Cultural and religious background influences dream culture. If you grew up in a tradition that values dreams, you probably remember them more and find them more significant. If your culture dismisses dreams as meaningless, you might too. But individuals vary within cultures. Some people develop strong dream attention despite dismissive cultural context, while others ignore dreams despite cultural emphasis on them. Personality affects dream culture. Creative, imaginative, introspective people tend to remember more dreams and find them more interesting. Concrete, practical, externally focused people tend to remember fewer dreams and care less about them. Neither type is better. They're just different orientations toward inner life and subjective experience. Life circumstances matter too. During stressful periods, dreams might become more intense, more memorable, harder to ignore. During stable, peaceful periods, dreams might fade to background, less urgent, less demanding of attention. Pregnancy, illness, major transitions, all can change dream frequency and intensity, temporarily shifting your dream culture. You get to choose your relationship with dreams. You can journal systematically or never. You can analyze dreams deeply or let them go completely. You can share dreams with others or keep them private. You can seek symbolic meanings or take dreams literally or dismiss them as random. Dreams are yours. You determine how they fit into your life, how much attention they deserve, what significance you assign them. For tonight, you don't need to decide. You don't need a dream policy or interpretation framework. Dreams will come. Some you'll remember. Most you'll forget. Some might feel significant, others won't. Whatever happens is fine. Your unconscious will do its work regardless of your conscious relationship with dreams. Whether you remember or forget, interpret or ignore, value or dismiss sleep, and dreams will serve their functions. Your brain will cycle through its nightly processes. Morning will come. So release any pressure around dreams. They don't need your management or understanding to work properly. They're happening in you for you as you, with or without your conscious participation. Rest in that. Let dreams be what they are, natural, mysterious, yours, unfolding every night in the private theater of your sleeping mind. While you sleep, your brain is busy transferring memories from temporary to permanent storage. During the day, new experiences are encoded in the hippocampus, a seahorse-shaped structure deep in the brain. But hippocampal storage is limited, temporary, fragile. These fresh memories need to be transferred to the cortex, distributed across brain regions for long-term storage. This transfer consolidation happens primarily during sleep. During slow-wave sleep, deep sleep, the hippocampus replays experiences, patterns of neural activity that occurred during learning fire again, often faster than real-time, compressed into brief bursts. This replay happens thousands of times per night. Each replay strengthens connections between the hippocampus and cortex, gradually transferring information from temporary to permanent storage. During REM sleep, consolidation continues. but with different characteristics. REM seems especially important for integrating new information with existing knowledge, finding patterns, making connections. If slow-wave sleep is about storing individual memories, REM is about organizing them, linking them to related memories, building the vast associative network that comprises your knowledge. This process isn't passive copying, it is active processing. Your brain doesn't just file memories, it edits them, strengthens important elements, discards irrelevant details, extracts patterns and meanings. When you wake, memories are transformed, less exact, more meaningful, integrated with broader understanding. You remember the gist, the significance, the pattern, more than the precise details. Brain scans confirm this activity. Researchers can watch specific brain regions that were active during learning reactivate during sleep. If someone learns a maze task, navigation areas fire during learning and then fire again during sleep. The same patterns, the brain rehearsing, strengthening, consolidating. This replay is so specific that researchers can sometimes predict what someone was learning based on their sleep brain activity. The consolidation process is selective. Not everything gets consolidated equally. Emotionally significant events are prioritized. The brain tags them as important, replays them more frequently, stores them more durably. This is why you remember emotionally charged events better than neutral ones. Sleep's consolidation process respects emotional significance, ensuring important experiences are preserved. Social and personal relevance also matters. Information relevant to your goals. Your identity, your relationships consolidates better than irrelevant information. Your brain is curating, deciding what deserves permanent storage based on significance to you specifically. This personalization means your memory isn't just an archive, but a reflection of your values, concerns, and identity. Consolidation also requires forgetting. You can't remember everything. That would be overwhelming, computationally expensive, dysfunctional. So sleep's process includes deliberate forgetting, weakening connections to irrelevant details while strengthening relevant patterns. This isn't failure, it is intelligent curation. Sleep makes you a better editor of your own experience, keeping signal and discarding noise. Tonight as you sleep, this process will unfold. Today's experiences, conversations, sights, thoughts, learnings will be replayed, processed, filed. Some will consolidate into permanent memory, others will fade. Your brain will decide using criteria honed by evolution, emotional significance, personal relevance, pattern importance. By morning, today will be part of your past, integrated into the ongoing story of your life, stored in neural networks that make you who you are. Dreams often contain fragments of recent experiences, people you saw today, places you visited, problems you're working on. These aren't random inclusions, they're signs of memory consolidation happening. You're witnessing the process subjectively, experiencing your brain's work as dreams. The day residue effect is well documented. Experiences from the previous 1 or 2 days frequently appear in dreams. Meet someone new, they might show up in tonight's dream. Watch a movie scenes, or themes might infiltrate your dreams. Face a problem, you might dream about it, or about metaphorically related scenarios. Recent experiences are fresh, actively being consolidated, so they surface in dreams. But dreams also pull from older memories, sometimes surprisingly old. You might dream about someone you haven't seen in years, triggered by something in today's experience that shares qualities with that old memory. Maybe you saw someone who resembled them, or experienced an emotion you associate with them, or visited a place that reminds you of a place you knew together. Your brain is linking new to old, connecting today's experiences to your historical database. This linking is why dreams are so bizarre. When your hippocampus replays recent memories and your cortex searches for related stored memories, sometimes the relationships are obvious, sometimes obscure. Your boss appears with your mother's face. Maybe they both represent authority. Your childhood home contains your office furniture. Maybe both are workspaces. The connections your brain makes aren't necessarily conscious or logical. They're based on deep associative links, emotional similarities, pattern matching at levels you don't access consciously. Some researchers suggest dreams are the subjective experience of memory consolidation. You're feeling your brain work. The narrative your conscious mind constructs from this work is the dream. The consolidation process isn't inherently narrative, but your consciousness imposes narrative structure, creates stories from the fragmented replay, makes sense of the neural activity as best it can. This explains why dreams are fragmented and shift unexpectedly. Memory consolidation isn't linear. The brain jumps between different memory clusters, activates one set of memories, then another, based on associative connections rather than logical progression. Your consciousness experiences these jumps as scene shifts, sudden changes in dream content, the characteristic disjointedness of dreams. It also explains dream emotions. Memories being consolidated often carry emotional weight. That is why they're being processed. When your amygdala reactivates as part of consolidating an emotional memory, you feel that emotion in the dream. You're re-experiencing feelings attached to memories being worked on. Sometimes this is appropriate to dream content. Sometimes emotions seem disproportionate to dream events because the emotion belongs to a memory being processed, not to the dream scenario your consciousness has constructed. Creative connections in dreams might result from memory consolidation's associative nature. Your brain is finding unexpected connections, linking disparate experiences, discovering patterns across different domains. Sometimes these connections are genuinely useful insights, solutions, creative ideas that wouldn't occur during waking's more linear thinking. Sometimes they're just odd combinations that seem profound during the dream but meaningless upon waking. Either way, dreams reveal your brain working, sorting, organizing, connecting, consolidating. The strange theater of dreams is memory processing made visible, or at least experienceable. You're getting a glimpse, however distorted and indirect, of your brain doing essential cognitive work, building the memory structures that allow you to learn, grow, and maintain identity across time. The relationship between sleep and learning is profound and well established. You learn better when you sleep after learning. Sleep protects new memories from interference, consolidates them, sometimes even enhances them beyond the level achieved while awake. Students who sleep after studying perform better on tests than students who stay awake the same amount of time. Sleep isn't passive time. This applies to all kinds of learning. Declarative memory facts, events, explicit knowledge, benefits from sleep. Study vocabulary, sleep, and you'll remember words better than if you stayed awake. Learn historical dates, sleep, and consolidation happens. The hippocampus to cortex transfer occurs during sleep, making explicit knowledge more durable and accessible. Procedural memory skills. How to knowledge motor learning also benefits dramatically from sleep. Practice piano, sleep, and tomorrow your fingers will know the piece better. Practice a sport, sleep, and performance improves. This isn't just about physical rest for muscles, it is about motor cortex consolidation. Your brain is rehearsing movements during sleep, strengthening neural pathways, optimizing motor sequences. Musicians and athletes know this empirically. They practice to a point, then sleep, and find improvement the next day without additional practice. The improvement happened during sleep neural rehearsal, consolidation, optimization. Some athletes report dreaming about their sport, experiencing their movements in dreams. Whether these dreams cause the improvement or are side effects of motor consolidation doesn't matter. Sleep is doing essential work for skill development. Complex problem solving improves with sleep. Studies give people puzzles, let some sleep and others stay awake, then retest. Sleepers show more insight, solve problems they couldn't before, find creative solutions. Sleep provides a eureka boost, especially REM sleep, possibly because REM's loose associations and reduced prefrontal control allow new mental combinations, fresh approaches, insights that waking's logical constraints prevent. This doesn't mean sleep magically solves problems, but it facilitates problem solving by reorganizing information, making new connections, approaching challenges from different angles. Sleep on. It is good advice backed by research. Your sleeping brain will work on problems, perhaps find solutions, at minimum provide fresh perspective when you wake. Sleep deprivation impairs learning severely. Miss sleep and you can't encode new memories effectively. Your hippocampus doesn't function well without adequate sleep. Information you do encode doesn't consolidate properly, remaining fragile and easily forgotten. Attention, focus, working memory all decline with sleep loss, making learning during waking harder too. Sleep debt accumulates, creating increasing cognitive impairment. Students who pull all-nighters perform worse than students who study less but sleep. The additional study time doesn't compensate for lost consolidation. Better to study moderately and sleep well than study extensively and skip sleep. Teachers and parents who understand this encourage sleep, recognizing it as essential study time, not time stolen from learning. The practical wisdom is clear: prioritize sleep when learning. Study, then sleep. Practice, then sleep. Work on problems, then sleep. Your brain needs sleep to make learning stick, to transform practice into skill, to convert experience into knowledge. Sleep isn't downtime. It is when learning completes, when today's efforts become tomorrow's competencies. Tonight you'll sleep, and whatever you learned or experienced today will be working its way into permanent storage. Skills you practiced will be refined. Information you encountered will be filed. Problems you considered will be processed. Your brain doing its essential work while you rest, ensuring that today matters for tomorrow, that experience accumulates into expertise, that you wake more capable than when you slept. Sleep helps you forget, and this is good. Forgetting isn't memory failure, it is memory curation. You can't remember everything. Your brain would overflow, processing would slow, finding relevant memories would become impossible. Efficient memory requires selective retention. Keep important information. Sleep does this. During sleep, your brain strengthens some memories while letting others fade. The technical term is synaptic homeostasis. Throughout the day, learning creates new synaptic connections and strengthens existing ones, increasing overall neural activity. This can't continue indefinitely. Neurons would become oversaturated, unable to form new connections or distinguish important from unimportant information. Sleep downscales synaptic strength globally while selectively preserving important connections, effectively pruning the neural network, creating space for new learning. This selective preservation means emotionally significant, personally relevant, or frequently encountered information survives downscaling while trivial details fade. You remember the gist of conversations, but not exact wordings, unless emotionally charged. You remember the essence of experiences, but not every perceptual detail. Your brain is compressing, extracting signal from noise, building abstraction and understanding rather than archiving everything. This forgetting serves creativity and problem solving. Memories with irrelevant details stripped away are easier to recombine, easier to apply to new situations. If you remembered every specific instance of using a tool, generalization would be difficult. But by forgetting specifics and retaining patterns, you develop flexible knowledge applicable across contexts. Sleep facilitates this abstraction, transforming episodic memories, specific events, into semantic knowledge, general understanding. Dreams might participate in selective forgetting. While consolidating important memories, your brain might be actively disengaging from unimportant ones, rehearsing what matters while letting what doesn't fade. The strange combinations in dreams, important elements mixed with trivial details, might reflect this sorting process, significant memories being integrated while insignificant details float disconnected, soon to be forgotten. REM sleep seems particularly involved in emotional memory processing, which includes both strengthening emotional memories and reducing their emotional charge. A traumatic experience might be consolidated. You remember what happened. While emotional intensity decreases, it bothers you less. This emotional depotentiation is adaptive. You need to remember dangers for future avoidance, but you don't need the trauma to remain fresh and overwhelming. Sleep processes emotional memories, keeping information while reducing distress. This process can malfunction. In PTSD, emotional memories don't properly depotentiate. They remain raw, intrusive, overwhelming even years after events. The consolidation system seems stuck, unable to transform hot memories into cool ones. Understanding this helps explain PTSD's persistence and suggests therapeutic targets, helping the system complete processing it started, but couldn't finish. For normal forgetting, sleep's curation is benign and beneficial. You don't lose important information. You lose clutter. You don't forget experiences that matter. You forget trivia that would clog your mental system if retained. By morning, your memory is cleaner, more efficient, better organized than when you slept. This means accepting forgetting as healthy rather than fearing it. Yes, you'll forget most of today, most details, most trivial events, most unimportant information, and that is good. What matters will remain. What is emotionally significant will stick. What you need for functioning and identity will be preserved. Your brain is handling this automatically, sorting while you sleep, ensuring your memory serves you rather than burdening you. Sleep enhances creativity in measurable ways. After sleep, people generate more creative solutions, make more unusual associations, solve problems requiring insight more successfully. REM sleep particularly correlates with creative enhancement, possibly because REM's brain state vivid imagery, loose associations, reduced prefrontal control, mimics conditions that facilitate creativity while awake. Famous creative insights reportedly came from dreams. August Keckel dreaming of a snake biting its tail, inspiring the benzene ring structure. Dmitry Mendeleev dreaming the periodic table arrangement. Elias Howe dreaming about spears with eye-shaped holes near their tips, solving his sewing machine needle design problem. Paul McCartney dreaming the melody for Yesterday. These anecdotes are often embellished, but the pattern is clear. Many creative people report dreams providing inspiration, solutions, artistic material. Whether dreams directly cause insights or just precede them is debatable. Maybe the creative work happens during sleep, and dreams are how you experience it. Maybe sleep primes for creativity, and insights come upon waking. Either way, the connection between sleep, dreams, and creativity is real. Artists, musicians, writers, scientists, many deliberately use sleep for creative work, trusting their unconscious to process problems overnight. Research supports this connection. Studies show that REM sleep specifically enhances creativity. People awakened from REM perform better on creativity tests than those awakened from other sleep stages or kept awake. The effect is strongest for problems requiring unconventional thinking, novel combinations, seeing relationships between disparate elements, exactly what REM's loose associative process facilitates. REM's neurotransmitter profile supports creativity. Acetylcholine is high, supporting vivid experience and memory access. Norepinephrine is low, reducing focus and executive control. Serotonin is low, allowing unusual mental combinations. This neurochemical state permits mental activity that would be inhibited while awake. Thoughts wander more freely, constraints relax. Impossible ideas get entertained rather than immediately rejected. Dreams show this creative process subjectively. You experience novel scenarios, impossible events, unexpected combinations. The bizarreness of dreams is creativity operating without waking constraints. Most dream creativity is random and useless, but occasionally it produces something valuable. An image that inspires art, a scenario that suggests a story, a problem-solution connection that waking thinking missed. Lucid dreamers can leverage this deliberately. Knowing they're dreaming, they can pose questions, explore problems, experiment with ideas. The dream provides a virtual laboratory where mental constraints are loosened. Imagination runs freely. Possibilities can be tested without real-world limitations. Some artists and inventors reportedly use lucid dreams systematically for creative development. Even without lucidity, keeping dream journals helps creativity. Writing dreams down captures their content, which might include useful material, images, ideas, phrases. Reviewing dream journals, patterns emerge, themes recur, and these might spark creative projects. The journal becomes a repository of unconscious material that waking consciousness can mine for inspiration. The key is trusting the process without demanding results. If you go to sleep trying hard to solve a problem, anxiety interferes with sleep quality. But if you gently hold a question, acknowledge you're working on something, then release it and sleep. Your brain might work on it overnight. Not always, not predictably, but often enough to be worth the practice. Sleep becomes collaborative. You work during waking, your unconscious continues during sleeping, and together you achieve more than either could alone. Tonight, if you're working on anything creative, know that sleep will contribute. Your brain will process, connect, explore while you rest. You might wake with inspiration, might not, but either way the work will have continued underground. Trust sleep's creativity. Trust your dreaming mind to surprise you with connections, insights, material that your waking mind couldn't generate. Sleep is creative time, and dreams are where creativity appears, sometimes random, sometimes profound, always worth paying attention to. Consciousness, your subjective experience, The feeling of being you, the inner world of thoughts and sensations, is one of science's deepest puzzles. We can study brain activity, identify which neurons fire when you see red or feel pain or make decisions, but we can't explain why neural activity creates subjective experience. Why doesn't it all happen in the dark mechanistically without any inner felt dimension? This is the hard problem of consciousness, and it remains unsolved. Dreams make this problem even more interesting. During dreams, you have rich subjective experiences, seeing, hearing, feeling generated entirely by your brain without external input. There is no light entering your eyes, yet you see, no sound entering your ears, yet you hear. Your brain is creating consciousness from pure internal activity. This reveals something crucial. Consciousness doesn't require external world. It is something your brain generates, not something that passively receives reality. If your brain can create entire convincing worlds during sleep, what about during waking? Your waking experience might also be constructed, not directly perceived. You think you're seeing reality, but you're actually seeing your brain's model of reality. Built from sensory data plus expectations, memories, predictions. Dreams show this construction process nakedly, pure construction without external input, revealing what your brain does all the time. Usually constrained by sensory information, but fundamentally creative. Philosophers have noted this for centuries. How do you know you're not dreaming right now? Descartes famously asked this, using dreams to motivate skepticism about reality. You can't definitively prove you're awake. Dreams feel real while you're in them. Only after waking do you recognize the dream as dream. This suggests that certainty about reality is hard to achieve, that consciousness could be fooled, that what seems most certain direct perception of reality might be illusion. Modern neuroscience doesn't quite validate radical skepticism, but it does show that perception is constructed. Your brain predicts what it expects to see, then checks predictions against sensory input. Most of what you see is predicted, not directly perceived. Dreams are what happens when prediction runs without correction, pure expectation becoming experience. This predictive processing framework makes dreams less mysterious and waking perception more dreamlike. Dreams also reveal consciousness's modularity. Different brain regions create different aspects of experience, vision, emotion, memory, self-awareness, logic. During dreams, some modules are active, vision, emotion, while others are quiet, logic, self-monitoring. This creates the distinctive phenomenology of dreams. Consciousness isn't one thing but a collection of processes that can combine in various ways, creating different states with different qualities. Understanding dreams as internally generated consciousness helps clarify what consciousness is and isn't. It is not something that exists independently and observes brain activity. It is brain activity, experienced from the inside. Different patterns of brain activity create different experiences, waking consciousness, dream consciousness, and all the variations within each. Dreams aren't separate from or inferior to waking consciousness. They're just a different configuration of the same underlying system. This is humbling and liberating. Humbling because it shows how thoroughly constructed your experience is, how much your brain creates rather than receives. Liberating because it shows consciousness is flexible, capable of many configurations, not locked into one mode. You experience multiple states, nightly waking, sleeping, dreaming, perhaps lucid dreaming, each revealing consciousness from different angles, each showing different capabilities and constraints. Tonight, as you dream, you'll be experiencing consciousness generating itself. No external world, just your brain active in particular patterns, creating sights and sounds and feelings from pure neural activity. It is remarkable, really, this capacity to create experience from nothing but electrochemical processes. It is what makes you conscious, what makes life felt rather than merely lived. Dreams remind you of this gift every night. Consciousness experiencing itself, aware of awareness, the strange loop of being that makes you you. The hard problem of consciousness asks, why is there subjective experience at all? Why does information processing in the brain feel like something? Why does seeing red feel different from seeing blue when both are just different neural patterns? Why does pain hurt when it is just signals about tissue damage? Why is there an inner world, a felt dimension to existence, rather than just mechanical processes happening in the dark? No one has solved this problem. We can correlate neural activity with subjective experiences. This pattern correlates with seeing red, that pattern with feeling pain. But correlation isn't explanation. Why those particular neural patterns create those particular experiences remains mysterious. Even if we mapped every neuron and understood all connections, we'd still face the question, why does this physical system generate subjectivity? Dreams sharpen this problem. Look at visual dreams. Your occipital cortex fires, creating patterns similar to those produced when you actually see something. But there is no light, no external input. The experience of seeing is generated purely internally. If we could map your brain during a dream, we'd see the visual cortex active and could potentially identify what you're dreaming about. But we still wouldn't explain why that neural activity creates the subjective experience of seeing. Some philosophers argue dreams might provide hints towards solving the hard problem. If consciousness can exist without external input, maybe it is more fundamental than we think. Maybe consciousness isn't produced by brain activity, but is something brains tap into or configure. This sounds mystical, and mainstream neuroscience mostly rejects it. But the hard problem is so hard that some researchers consider even radical solutions. Others argue dreams don't make the hard problem harder or easier. They just demonstrate it in a different context. Whether consciousness arises from processing external stimuli or internal generation, the question of why it arises at all remains. Dreams are consciousness operating in offline mode, which is interesting but doesn't explain consciousness's existence any more than waking does. One interesting angle, dreams sometimes feel more conscious than waking. Many people report that certain dreams are more vivid, more intense, more real feeling than ordinary waking. Lucid dreams especially can feel hyper-real, with colors more saturated, sensations more intense, awareness more acute. If consciousness were simply produced by sensory input, this wouldn't make sense. But if consciousness is generated internally, with sensory input actually constraining or dulling it, then dreams' occasional hyper-vividness makes sense. Another angle, dreams demonstrate that consciousness operates on a spectrum. You're not simply conscious or unconscious. You're conscious in different degrees and flavors. Waking consciousness, light sleep consciousness, dream consciousness, lucid dream consciousness, deep sleep consciousness, if any exists. This spectrum suggests consciousness isn't a binary property, but a multi-dimensional state space with many possible configurations. The hard problem might be intractable, something we'll never fully solve. Not due to ignorance, but because of consciousness's nature. Maybe subjective experience is fundamentally first-person, and any third-person scientific explanation will miss something essential. You can't fully explain what red looks like to someone who has never seen it. You have to experience it. Similarly, maybe consciousness can't be explained from outside, only experienced from within. If that is true, dreams are important not because they solve the hard problem, but because they're another way to experience consciousness, another angle from which to understand it. You can't explain dreams in ways that fully capture what they feel like. You have to dream, and in dreaming, you're learning about consciousness directly, not intellectually, but experientially, encountering the hard problem from the inside where it is not a problem, but just the fact of being. As you drift towards sleep, this hard problem is about to manifest again. Your consciousness will shift from waking to sleeping to dreaming, moving through configurations that feel profoundly different yet are all you. The mystery of why this feels like anything will remain unsolved and perhaps unsolvable. But you'll experience it fully, living the hard problem rather than solving it, which might be the only resolution consciousness permits. Your brain is modular, composed of many specialized regions and networks, each contributing different functions to overall consciousness. Visual cortex processes sight, auditory cortex processes sound, motor cortex plans movement, prefrontal cortex handles executive functions, limbic system generates emotions, default mode network constructs self-narrative. These modules work together, integrated into unified experience, but they separable, capable of operating independently or in different combinations. Dreams demonstrate this modularity clearly. During REM dreams, visual and auditory cortices are active. You see and hear. Motor cortex is active. You experience movement. Limbic system is highly active. Strong emotions. but prefrontal cortex is relatively quiet, reduced logic and self-awareness. This specific combination creates dream phenomenology, vivid, emotional, illogical, immersive. Change the combination, and you get different experience. In lucid dreams, prefrontal cortex partially reactivates, while maintaining other REM characteristics. This adds self-awareness and some executive control to the dream state. You are now combining modules differently. Visual cortex active, seeing dreams plus emotional centers, active, feeling emotions, plus prefrontal cortex partially active, knowing you are dreaming, exercising some control. The result is a hybrid state, neither typical dreaming nor typical waking, but its own configuration. Deep sleep might have minimal consciousness. Visual, auditory, emotional, and prefrontal cortices all relatively quiet, leaving mostly baseline neural maintenance. If there is any experience during deep sleep, it is probably vague, unstructured, not remembered, consciousness at its minimum. Few modules contributing, meditation can create yet other configurations. Some meditation states involve high frontal activity, focused attention, with reduced default mode activity, less self-narrative. Others involve reduced activity across most networks, relaxation, emptiness. Each creates distinctive subjective experience, focused clarity, spacious emptiness, absorbed flow, showing how reconfiguring active modules changes consciousness. Flavor. Psychoactive substances alter module activity too. Psychedelics like LSD or psilocybin reduce default mode network activity, while increasing cross-talk between normally separate networks. This creates synesthesia, ego dissolution, novel insights, consciousness reconfigured pharmacologically into states ordinarily inaccessible. Dreams might share some neural features with psychedelic states, both involving reduced default mode and increased visual emotional activation. This modularity explains why consciousness has so many varieties. It is not just on or off, present or absent. It is a space with many dimensions, each module's activity level being one dimension. Move through this space by changing which modules are active and at what levels, and you experience the full range of human consciousness. Waking, sleeping, dreaming, meditating, intoxicated, lucid, flowing, distressed. All different positions in consciousness space. Disorders also reveal modularity. In some syndromes, specific modules malfunction, while others work normally. Prosopagnosia, face, blindness, visual cortex works but face, processing module does. Capgras syndrome, face recognition works but emotional connection doesn't, creating belief that loved ones are imposters. Synesthesia, sensory modules cross-talk abnormally, creating mixed sensations. Each shows how consciousness emerges from modular components that can separate, malfunction, recombine. Understanding consciousness as modular helps explain both its unity and its multiplicity. Unity, normally, modules integrate seamlessly into one cohesive experience. You don't feel like a collection of parts. You feel like oneself having one experience. Multiplicity, separate modules, means the integration can vary, creating different states, different flavors of consciousness, different ways of being. Dreams are one way your brain demonstrates this flexibility, showing you nightly that consciousness isn't fixed, but fluid. Not one thing, but many configurations. Not static, but dynamically reconfigurable. You exist in different states throughout each 24 hours. Consciousness shifting as your brain shifts. And all of it is you. All of it is valid. All of it is the modular brain, creating experience from its many parts working in countless combinations. Discovered in the early 2000s through brain imaging, the default mode network, DMN, is a set of brain regions that activates when you are not focused on external tasks. When you are daydreaming, mind, wandering, remembering the past, imagining the future, thinking about yourself. The DMN is sometimes called the narrative self network because it constructs your sense of identity, your life story, your continuity through time. Key DMN regions include medial prefrontal cortex, posterior cingulate cortex, medial temporal lobes, including hippocampus, and parts of parietal cortex. These regions work together, creating the internal mental space where you reflect on yourself, plan for the future, remember the past, construct meaning and narrative from experience. During focused external tasks, the DMN quiets. Its activity inversely correlates with task. Focused networks. When you are paying attention to something outside yourself, when you are not focused externally, the DMN activates, and your mind turns inward. This is why you can help at mind wander during boring tasks. Your DMN keeps activating, pulling you into internal thoughts and daydreams. Dreams involve DMN in interesting ways. During REM, parts of the DMN are active, but the pattern differs from waking. The posterior regions, posterior cingulate and medial temporal lobes, are active, accessing memories, creating sense of self. But anterior regions, medial prefrontal cortex, are relatively quiet, reduced executive control, less meta-awareness. This might explain why you have some sense of self in dreams. You are there experiencing, though sometimes as someone else, but lack full self, monitoring, and perspective. This partial DMN activation creates dream's characteristic self-experience. You are present in the dream, but you are not watching yourself from outside, not judging or analyzing, not fully aware of yourself as dreamer. You are immersed, identified with the dream, self-experiencing without the distance that waking self-awareness provides. Interestingly, studies show that what people think about during mind wandering and what they dream about are similar. Both draw on personal concerns, future plans, past memories, social relationships. This suggests overlap between daydreaming and dreaming. Both are internally generated experiences involving DMN. Both process personal material. Both create narratives from memories and concerns. Some researchers propose that dreams are intensified mind wandering. What happens when mind wandering continues without reality constraints or external interruptions? During waking, mind wandering is checked by environment, tasks, social demands. During sleep, these checks are absent, so internally generated narrative runs freely, unconstrained, becoming the vivid, extended, bizarre stories we call dreams. The DMN is implicated in depression and anxiety. Overactive DMN correlates with rumination, repetitive negative thought about self and problems. Treatments that reduce rumination often reduce DMN activity. Sleep problems in depression often include disrupted REM and nightmares, possibly reflecting DMN dysfunction. The narrative self network stuck in negative loops, even during sleep. Meditation practices often aim to quiet the DMN, reducing self-referential thought, ego identification, narrative construction. Experienced meditators show reduced DMN activity, correlating with subjective reports of ego dissolution, spacious awareness, freedom from self-centered thinking. This suggests DMN activity is partly responsible for ordinary sense of self, and reducing it changes self-experience fundamentally. Dreams might serve DMN maintenance, keeping the narrative self network active and functional, rehearsing self-relevant scenarios, consolidating autobiographical memories, integrating new experiences into ongoing life narrative. Your dreams are your DMN working, maintaining your sense of identity and continuity, ensuring that when you wake, you still know who you are, where you fit in your life story, what matters to you. Tonight, your DMN will be active during dreams, creating that familiar sense of being you in various scenarios, even strange scenarios, even when you are someone slightly different in the dream. The network that constructs your waking identity will be constructing your dream identity, maintaining selfhood even in sleep, ensuring continuity across states, keeping you yourself throughout consciousness. Many configurations. A relatively new theory in neuroscience suggests that consciousness is fundamentally about prediction. Your brain constantly predicts what will happen next based on past experience, then checks predictions against incoming sensory data. Perception is this prediction-checking loop. You don't passively receive reality, you actively predict it, then update predictions when reality differs from expectation. This framework explains many phenomena. Optical illusions work because your predictions override sensory data. You see what you expect to see, not what is actually there. Attention works by allocating resources to things prediction is uncertain about. You notice unexpected things because they violate predictions. Learning happens through prediction errors. When reality doesn't match expectation, you update your model. Dreams fit this framework beautifully. During dreams, there is no sensory input to check predictions against, so predictions run unchecked. Your brain generates expectations based on memory, emotion, concerns, and those expectations become experience without reality correction. This explains dream content drawn from memory, because predictions are based on past experience, emotionally charged because emotions affect predictions, bizarre because predictions can violate reality without being corrected. It explains dream acceptance of impossibilities. Your brain predicts something, and with no sensory data contradicting it, the prediction becomes reality. You predict you can fly, and you fly. You predict this person is both your friend and your boss, and they are both simultaneously. Without sensory reality enforcing consistency, predictions can be impossible, contradictory, bizarre. It explains why dreams feel real. Predictions generate full subjective experience, indistinguishable from perception. Your visual cortex fires whether it is processing sensory input or internal predictions. Either way you see. To your consciousness, predictions and perceptions are identical until proven otherwise. Dreams prove nothing otherwise. They just run predictions as if they were perceptions, creating experiences that feel completely real. Waking consciousness in this framework is just predictions constrained by sensory input. You're always generating predictions, but sensory data keeps them tethered to reality. Dreams are predictions freed from that constraint, showing what consciousness looks like when it is purely generative, unconstrained by external world. This also explains waking stability compared to dreams' instability. During waking, sensory feedback stabilizes predictions. You predict what you'll see, you see it. Prediction confirmed. Experience remains stable. During dreams, no feedback means predictions can shift wildly. One moment you're here, next moment there, nothing stabilizing the experience, allowing rapid scene changes, transformations, impossibilities. Lucid dreams fit the framework too. Gaining lucidity might mean your prediction system recognizes it is generating unchecked predictions, realizes no sensory data is coming in, concludes, I must be dreaming. This meta-prediction, predicting that you're in a prediction-only state, creates lucidity, awareness of dreaming while dreaming continues. Nightmares might be predictions running toward anxiety, generating threatening scenarios without reality to contradict them. If you're anxious, your brain predicts threats, and in dreams, those predicted threats become experienced reality, spiraling into nightmare. The lack of reality checking means anxious predictions can escalate without limit, creating intense fear. This predictive framework is still being developed and debated, but it offers elegant explanations for many dream phenomena. It also suggests that waking and dreaming aren't fundamentally different. Both are consciousness predicting experience. Dreams just do it openly, visibly, without pretense of external constraint, showing you what your brain does all the time, generate reality. From internal models, expectations, shaping experience, consciousness, as prediction made manifest. As you sleep and dream tonight, you'll be experiencing prediction without correction, your brain generating expected realities and experiencing them as if they were actual. It is not different in kind from waking, just different in degree. Waking predictions constrained, sleeping predictions free. Both are your brain doing what it does best, creating experience, building worlds, making consciousness from pure neural activity. Predictions, all the way down. After all this exploration, through sleep stages and REM cycles, through memory consolidation and emotional processing, through neuroscience and philosophy, we arrive at a simple truth. We still don't fully understand dreams. We know much more than we did 50 years ago, much more than ancient dream interpreters did, but fundamental questions remain unanswered. And that is not only okay, it is somehow appropriate, even beautiful. We can describe what happens when you dream. We can point to brain regions that activate, neurotransmitters that rise and fall, sleep stages that cycle. We can show that REM exists, that it serves functions, that it correlates with vivid dreaming. We can measure, observe, document, but we can't fully explain the essential mystery. Why does any of this feel like anything. Why do patterns of neural firing create the subjective experience of seeing faces, hearing voices, feeling emotions, being somewhere? The hard problem of consciousness, why physical processes create subjective experience, persists. We haven't solved it for waking consciousness, and we certainly haven't solved it for dreaming consciousness. We can correlate brain states with dream reports, but we can't explain why those particular brain states generate those particular experiences. The gap between objective description and subjective experience remains. We also don't know definitively why we dream. Yes, we have theories: memory consolidation, emotional processing, threat simulation, neural maintenance. Each theory has evidence, but none is proven conclusively. Maybe dreams serve all these functions simultaneously. Maybe they serve functions we haven't discovered. Maybe they don't serve functions at all, but are byproducts of processes that do. We have good hypotheses, but not certainty. We don't fully understand dream content, why you dream about specific things, why memories combine in particular ways, what determines which memories surface and which don't. We know general principles. Recent experiences appear. Emotional events are more likely. Personal concerns shape content. But we can't predict your specific dreams, can't fully explain why you dreamed what you dreamed last night rather than something else. We don't know why some people remember dreams frequently while others rarely do, beyond general factors like REM interruption and attention to dreams. We don't know why dream recall varies so much night to night, even in the same person. We don't fully understand individual differences in dream phenomenology, why some people dream in vivid color and others don't, why some have narrative dreams and others fragmentary ones. Lucid dreaming remains somewhat mysterious. We know it involves prefrontal cortex reactivation, but we don't know exactly what triggers spontaneous lucidity, why some people lucid dream naturally, while others never do, what determines when lucidity occurs. We're learning, but much remains unknown. The relationship between dreams and creativity, insight, problem solving is established, but not fully understood. We know sleep helps, but we don't know precisely how, which aspects of dreams, if any, are essential, whether the subjective experience matters, or just the neural processes underneath. And perhaps most fundamentally, we don't know what consciousness is. We don't know why it exists, how it arises from matter, what its nature is. Dreams are consciousness in a particular configuration, but if we don't understand consciousness generally, we can't fully understand dreams specifically. The mystery of dreams is nested within the larger mystery of consciousness, which might be the deepest mystery science faces. But not knowing doesn't mean we've learned nothing. We know much. We've mapped sleep architecture, identified REM's characteristics, studied memory consolidation, documented emotional processing. We've learned enough to help people sleep better, treat nightmares, understand why sleep matters. Knowledge is real even when incomplete, and incompleteness leaves room for wonder. If we knew everything about dreams, they'd become mundane, just another explained phenomenon. Mystery keeps them interesting, keeps them worthy of attention, keeps them capable of surprising us. Not knowing everything about dreams means each dream is still a small mystery, still an opening into something not fully understood, still a gift, rather than a solved problem. Dreams deserve reverence, not religious reverence necessarily, though many traditions see dreams as spiritually significant, but reverence in the sense of honoring something valuable, treating it with respect, recognizing its importance to your life and consciousness. Dreams are sacred space in your psyche, private, personal, mysterious, yours alone. Consider the numbers. You spend about 1/3 of your life asleep. Of that, roughly 20 to 25% is spent in REM, which means about 6 years of an average human life are spent in dream states. 6 years, that is not trivial time. That is a substantial portion of your existence, spent in experiences that are completely internal, generated by your own mind, visited by you alone. No one else can witness your dreams directly. They're entirely subjective, entirely private. You can describe them, but description never fully captures them. Dreams are your secret inner life, experiences known only to you. This privacy is precious, a mental space completely your own, unreachable by others, ungovernable by external forces. Dreams are also creative in the deepest sense. While awake, creativity is constrained by physics, by logic, by social norms, by practical limits. But in dreams, your mind creates freely. Entire worlds appear, complete with details you never consciously invented. People speak, saying things you didn't plan. Scenarios unfold with narrative coherence, despite being unscripted. Your unconscious is an artist, a storyteller, a world builder, creating nightly exhibitions that only you attend. This creative capacity is remarkable. You're capable of generating complex, coherent, detailed experiences from nothing but neural activity. You don't try to do this. It happens, automatically. Every night, your mind demonstrates extraordinary generative power, creating content that rivals the best fiction, the strangest art, the most profound philosophy, and you're both creator and audience, making and experiencing simultaneously. Dreams are also honest in ways waking thought often isn't. You can lie to yourself while awake, suppress uncomfortable truths, maintain illusions. But dreams don't lie. They can't. They arise from unconscious processes you don't control, revealing concerns you might not acknowledge, fears you might deny, desires you might hide, even from yourself. Dreams are your psyche speaking without censorship, without social politeness, without ego defenses, raw material from the unconscious. This doesn't mean every dream symbol has deep meaning. Many dreams are mundane, many are random combinations, many are just your brain processing, without particular significance. But dreams as a category, as a phenomenon, are honest. They show what is actually occupying your mental space, what your unconscious is working on, what emotions are alive in you, what memories are active. They're psychological truth tellers. Even when their truths are ordinary, dreams are also where you practice being. In dreams, you exist, experience, respond, feel all without any external consequences. You can make mistakes without cost, take risks without danger, explore possibilities without commitment. Dreams are a playground for consciousness, a rehearsal space for selfhood, a laboratory for experience. Whatever happens in dreams, you wake up and you're fine. This safety allows experimentation, allows you to be different selves, try different responses, explore different paths. Treating dreams as sacred doesn't require rituals or special practices. It just means acknowledging their value, their privacy, their creativity, their honesty. It means not dismissing them as just dreams, but recognizing them as genuine experiences, parts of your life worth honoring. You don't have to analyze every dream or keep elaborate journals. Just notice them, respect them, allow them space in your awareness. Tonight and every night, you'll enter this sacred space. Your private cinema, your personal dreamscape, your mind's nightly creation. It is yours. No one else will ever see it exactly as you do, ever experience what you experience there. Honor that privacy, that creativity, that mysterious gift your mind gives you every night, the gift of dreams, of internal worlds, of consciousness, exploring itself in the dark. There is a temptation, once you learn about dreams, to try to manage them, interpret them, control them, make them meaningful. Dream journals, lucid dreaming techniques, symbol dictionaries, interpretation systems, all trying to make dreams serve waking purposes, trying to extract value from them, trying to make them work for you. And while some of this can be interesting and useful, there is also value in a different approach, just letting dreams be. Dreams don't need your interpretation to function. They don't need you to remember them, analyze them, understand them, or learn from them to serve their purposes. Whatever those purposes are, dreams happen whether you pay attention or not. Memory consolidation, emotional processing, neural maintenance, all of it proceeds without your conscious participation. Your brain knows what to do, it doesn't need your help. This means you can release pressure around dreams. You don't have to remember them. Most dreams are forgotten, and that is fine. You don't have to keep a journal, though you can if you want. You don't have to interpret symbols or search for hidden meanings. You don't have to become lucid or control dream content. You can just let dreams happen, let them be what they are, without trying to make them something else. This non-grasping relationship with dreams is actually quite freeing. Dreams become less about accomplishment or understanding and more about simple experience. You dream, you wake, you go about your day. Sometimes you remember dreams, sometimes not. Sometimes dreams feel significant, sometimes not. All of it is fine. All of it is allowed. Dreams don't require performance or achievement or even awareness from you. Think of it like breathing. You breathe constantly, mostly without thinking about it. You can pay attention to breath if you want. Meditation does this. but you don't need to. Breath happens automatically, serving its functions, keeping you alive, whether you notice or not. Dreams are similar. They happen automatically, serve their functions, contribute to your mental health, whether you notice or not. Some people benefit from working with dreams intentionally, journaling, interpretation, lucid dreaming practice. For them, dreams are a rich area of exploration and development. That is wonderful, but it is not necessary. Other people never remember dreams, never think about them, never analyze them, and they sleep fine, function fine, live well. That is equally wonderful. There is no right way to relate to dreams, no obligation to do anything particular with them. The middle path might be gentle appreciation without effort. Notice dreams when you remember them. Enjoy interesting ones. Accept disturbing ones. Forget mundane ones. Don't force anything. Don't require anything. Don't make dreams into work. Just let them be part of your life, like weather. Sometimes sunny, sometimes stormy, always passing, always natural. This approach honors dreams without burdening them. Dreams remain what they are, spontaneous, mysterious, variable experiences that your brain generates nightly. You don't have to make them more than that or different from that. They're enough as they are. Your unconscious is creative enough, wise enough, capable enough to do its work without your conscious management. So tonight, as dreams come, you don't need to do anything. You don't need to remember, understand, control, or learn. You can just experience whatever arises, or not experience it if you don't remember. And either way is perfect. Dreams will happen. They'll serve their functions. They'll be what they are. And you'll wake in the morning, rested or not depending on sleep quality, having dreamed or not depending on memory, and life will continue, carried by processes that mostly happen without your awareness or control, and that is exactly how it should be. Wonder is the feeling of encountering something bigger than you understand, something mysterious and beautiful that exceeds your grasp. Children feel wonder easily. Everything is new. The world is magical. Mysteries are everywhere. Adults often lose wonder, becoming familiar with the world, explaining everything, reducing mystery to mechanism. But dreams restore wonder reliably, every night. No matter how much you learn about dreams, they remain surprising. You can study neuroscience, understand REM mechanisms, know about memory consolidation, and still be amazed by your own dreams. Still wake up thinking, where did that come from? How did my brain create that? The gap between understanding mechanisms and experiencing results is vast. You can know how dreams work generally and still find your specific dreams wondrous. Dreams prove that reality is stranger than you usually think. Every night, you leave consensus reality and enter private realities governed by different rules. Physics is negotiable. Time flows weirdly. Identities blend. Impossible things happen naturally. And you accept all of it until you wake, when suddenly the strangeness becomes apparent. You live in multiple realities, waking reality and dream realities, and move between them routinely, accepting both as real in their contexts. This is profoundly weird when you stop to think about it. You're a being that exists in multiple states, experiencing multiple kinds of reality, none of which is fully real in an objective sense. All are constructed by your brain. Waking reality is more constrained by external input, but it is still constructed, still a model. Dream reality is less constrained, more obviously constructed, but no less real as experience. You're flexible, multi-state capable, able to accept radically different realities, depending on consciousness configuration. Dreams also show you capabilities you don't normally access. Your brain can create entire worlds complete with consistent details. Realistic physics, even if strange physics, believable characters. Your visual imagination during dreams is often more vivid than during waking visualization. Your emotional range is broader. You feel things in dreams you might never feel awake. Your creativity is unleashed, combining elements in ways waking thought wouldn't, generating novel scenarios without trying. This means you're more capable than waking consciousness suggests. Your brain can do extraordinary things. You just don't usually witness them consciously. Dreams pull back the curtain, showing you the generative power that is always there, always working, usually below awareness. You're not just a receiver of reality, but a creator of experience, and dreams prove it nightly. There is wonder in memory too, how your brain stores decades of experience, millions of moments, and can access any of it in dreams. You might dream about someone you haven't thought about in years, and suddenly they're there, complete with details you didn't know you remembered. Your memory is vast, and dreams show you its vastness, pulling up material you thought forgotten, revealing how much you carry within you. There is wonder in continuity, how you remain yourself across all these states. You wake from dreams, and despite the strangeness of dream experience, you're still you. Same identity, same memories, same concerns. Consciousness persists across radical state changes, maintaining selfhood despite experiencing multiple realities. This continuity is remarkable. Something in you witnesses all states, remains stable through all changes, is always recognizably you. And there is wonder in the nightly cycle itself, how reliably sleep comes, how automatically you transition through stages, how your brain manages complex processes without your input. Every night, you die a little, losing consciousness, letting go of control, trusting processes you don't consciously manage. And every morning you resurrect consciousness, returning, continuity re-establishing, you waking up to be yourself again. This daily death and rebirth is so familiar, you don't notice it, but it is actually extraordinary. Dreams are a built-in source of wonder, a daily reminder that consciousness is mysterious, reality is flexible. You're capable of experiencing things beyond normal boundaries. They're a gift in this sense, providing regular contact with strangeness, with creativity, with the mysterious dimensions of being human. Even the most mundane life includes nightly adventures into impossible worlds. Even the most rational person experiences nightly encounters with their own unconscious creativity. Appreciating this wonder doesn't require belief in supernatural explanations or mystical interpretations. The scientific explanation is wonderful enough. Your brain generates experience from neural activity. Your consciousness creates worlds from memories and associations. You exist in multiple states, experiencing multiple realities, all of it perfectly natural and all of it deeply strange. Wonder and understanding can coexist. Knowing how doesn't diminish the amazement of that it happens at all. As this exploration draws toward its close, as you drift closer to sleep and dreams, it feels right to express gratitude. Gratitude for dreams themselves, for the capacity to dream, for the nightly gift of these mysterious experiences that enrich your life whether you notice them or not. Be grateful that you dream. Not everyone can. Some rare neurological conditions eliminate dreaming while leaving sleep intact. Some medications suppress dreams, but most likely you dream regularly, abundantly, creatively. Your brain generates these experiences nightly, without you asking, without you trying, without you earning them. They're given freely, part of being human, part of having a sleeping brain. Be grateful for REM sleep, for the complex choreography that allows dreams to happen safely. Your brainstem paralyzes your body, protecting you from acting out dreams. Your brain cycles through stages, providing both physical restoration and dream time. Neurotransmitters shift in precise patterns, creating conditions for vivid experience. All of this happens automatically, reliably, night after night, year after year, your entire life. Your brain takes care of everything without your conscious input. Be grateful for the variety of dreams, pleasant dreams that bring joy, strange dreams that entertain, even nightmares that, though difficult, might serve protective functions. Be grateful for mundane dreams that process daily life and profound dreams that feel meaningful. Be grateful for remembered dreams and forgotten ones, lucid and non-lucid, vivid and vague. All of them are part of your dream life. All contribute to your experience. All are expressions of your unique brain and psyche. Be grateful for what dreams reveal, your concerns, your creativity, your emotional life, your memory's vastness. Dreams show you yourself from angles you don't normally see, reveal contents of consciousness you don't usually access, demonstrate capacities you don't normally recognize. They're windows into your own mind, showing you what is there, what you're working on, what matters to you. Be grateful for the memory work dreams facilitate. Every dream that processes memories is helping you learn, helping you grow, helping you integrate experience into understanding. You wake each day slightly changed by night's work, experiences consolidated. Dreams contribute to who you become, how you develop, how you move through life. Be grateful for the creative inspiration dreams sometimes provide. Whether you use it consciously or not, your brain is exploring possibilities during dreams, making connections, generating ideas. Some dreams might inspire art, writing, problem solution. Others just maintain general creativity, keeping your mind flexible and generative. Either way, dreams contribute to your creative capacities. Be grateful for the emotional regulation dreams support. REM sleep helps process feelings, modulate responses, maintain emotional balance. You wake each morning emotionally recalibrated, at least partially, thanks to night's processing. Dreams might sometimes be emotionally challenging, but they're doing emotional work, helping you handle feelings, gradually integrating difficult experiences. Be grateful for the mystery that remains. Gratitude doesn't require complete understanding. You can be grateful for gifts without knowing exactly how they work or why they're given. Dreams are mysterious, and that mystery is part of the gift. It keeps them interesting, keeps them capable of surprising you, keeps them feeling special rather than routine. And finally, be grateful to yourself, to your brain, your body, your consciousness, for having this capacity. You're a being that sleeps and dreams, that exists in multiple states, that generates internal experiences of extraordinary richness. You're capable of this remarkably complex thing called dreaming, and that is worthy of appreciation. Your brain is doing something extraordinary every night, and you get to benefit from it, experience it, be changed by it. So thank you to your brain for dreaming, to your body for safely containing dreams, to your consciousness for experiencing them, to whatever forces led to you being a dreaming creature. Thank you to evolution for developing REM sleep, to your ancestors who passed down this capacity, to the universe for creating conditions where dreaming could evolve. Thank you to the mystery itself, for remaining mysterious, for keeping dreams wonderful, despite all we've learned about them. With gratitude, you can release into sleep. With gratitude, you can welcome dreams, whatever they bring. With gratitude, you can rest, knowing your brain will do its work, your consciousness will continue its nightly journey, and you'll wake tomorrow having dreamed, having benefited from dreams, whether you remember them or not. You've traveled far in this exploration. You've learned about sleep stages and REM cycles, about memory consolidation and emotional processing, about brain regions and neurotransmitters, about nightmares and lucid dreams, about cultural interpretations and philosophical implications. You've moved through science and mystery, knowledge and wonder, understanding and acceptance. And now, after all this journey through the landscape of dreams, you're returning to where we began, right here, right now, at the threshold of sleep. You're probably tired now. Your body has been settling throughout this listening, muscles relaxing, breath slowing, thoughts softening. The act of exploring dreams has been gently hypnotic, guiding you toward the very state we've been discussing. The information you've absorbed doesn't need to be consciously retained. It can settle into your unconscious, informing without demanding attention, enriching your relationship with dreams without requiring intellectual grip. Let it all go now. Let the facts fade. Let the theories drift away. Let the brain regions and neurotransmitters dissolve from conscious awareness. You don't need to hold on to any of it. What matters will remain, what doesn't won't, and that is perfect. Your brain knows how to learn during sleep, how to consolidate what is useful and release what isn't. Trust that process. Trust your sleeping brain to do its work. Notice where you are right now, your body resting, supported by whatever you're lying on. Your breath moving gently in and out, automatic and trustworthy. Your thoughts becoming less frequent, less distinct, less urgent. You're on the threshold, that familiar borderland between waking and sleeping, the space you've crossed countless times before and will cross countless times again. This threshold is safe. You've been here before, every night of your life. You've made this crossing. Your body knows how to do this. Your brain knows how to release waking consciousness and enter sleep consciousness. You don't need to try or manage or control anything. Just allow, just let go, just be here, gently, peacefully. As waking fades and sleeping approaches, the dreams are forming already, somewhere in the depths of your mind. Memories from today are being selected, associations are forming, emotional themes are emerging. Your unconscious is preparing tonight's experiences, assembling the raw material that will become dreams. You don't need to do anything to make this happen. It is happening automatically, naturally. Your brain has cycled through sleep and dreams every night of your life, tens of thousands of nights if you're an adult, creating expertise that exceeds any conscious knowledge. Your brain is a sleep expert, a dream expert, having done this so many times that it is automatic, reliable, trustworthy. You can surrender completely, knowing your brain will manage everything, will cycle you through stages, will generate dreams, will wake you in the morning. So begin the release now. Let waking go. Let consciousness soften. Let the day fade behind you. Let tomorrow fade ahead of you. Let everything condense into just this moment, just this gentle descent into sleep. You're safe. You're ready. The dreams are waiting. Tonight you'll sleep. It will unfold in predictable patterns, your brain following ancient rhythms, cycling through stages in the familiar 90-minute pattern that has been yours since birth. You'll descend first through light sleep, stage 1 briefly, then stage 2, your brain waves slowing, your body relaxing deeper, your consciousness dimming. Then you'll drop into slow wave sleep, the deepest rest, where delta waves roll through your cortex like ocean swells, where your body does its deepest healing. Growth hormone will release, tissues will repair, your immune system will strengthen, your brain's lymphatic system will flush away the day's accumulated waste products. This is restoration, renewal, your body taking care of itself while you are completely unconscious, completely unaware. After perhaps 30 or 40 minutes in deep sleep, you'll ascend, not back to waking but up through stage 2 again, and then into your first REM period. Your eyes will start moving behind closed lids, tracking dream imagery. Your brain will activate, becoming as busy as during waking. Your body will paralyze, keeping you safe, and you'll have your first dream of the night. This first dream might be brief, just 5 or 10 minutes. You probably want to remember it. It is a preview, a warm-up. Your brain testing the dream state. Beginning the night, psychological work. Memory processing will start. Emotional regulation will begin, but gently, quietly, without much conscious content that you lay into morning. Then the cycle repeats, down through light sleep, possibly another period of deep sleep, though shorter than the first, then back up to REM. Another dream, slightly longer, perhaps 15 minutes, then another cycle, another dream. Each time you descend and ascend, each time your brain cycles through its necessary stages, each time you dream a little longer, a little more vividly. By your 4th or 5th cycle, hours from now in the early morning, you'll spend 30 or 40 minutes in REM, having extended complex narrative dreams. These are the dreams you are most likely to remember, the ones that might stay with you into waking. These late-night dreams might be vivid, emotional, strange, memorable, or they might not be. Either way, they'll be doing their work, your brain engaged in its essential processing. Throughout the night, you'll be unconscious of most of this. You know you are cycling. Know when you are in deep sleep versus REM. Track the stages or monitor the process. Time will collapse. Hours will pass in what feels like moments, or perhaps no time at all. You'll emerge in the morning having experienced 8 hours that subjectively might feel like nothing, punctuated by a few remembered dream fragments, if you are lucky. And this is all automatic. Your brainstem, your hypothalamus, your thalamus, these regions will coordinate sleep stages without your input. Your neurons will fire in patterns perfected over millions of years of mammalian evolution. Your neurochemistry will shift precisely, acetylcholine rising and falling, norepinephrine dropping to near zero during REM, everything orchestrated without your awareness. You don't need to make any of this happen. You don't need to remember stages or worry about cycles or ensure you get enough REM. Your brain will handle everything. It knows what it is doing. It has done this thousands of times. Tonight will be no different. Your brain cycling you through sleep, generating dreams, doing its essential work while you rest, completely unconscious of the complexity, completely trusting the process. Somewhere in your mind right now, tonight's dreams are already taking shape. You can't see them yet, can't know what they'll be, but they're forming, drawn from today's experiences, from your memories, from your concerns and hopes and fears, from the vast database of your personal history. Your unconscious is an artist preparing tonight's exhibition, and you'll be the only audience. You might dream about people you saw today, someone you talked to, someone you passed on the street, someone you thought about. Their face might appear, or a version of their face, perhaps combined with others. perhaps transform. Your dream won't respect the boundaries of waking identity. People can be themselves, and also other people simultaneously, can shift and blend, and become composite characters that somehow make sense within dream logic. You might dream about places, familiar locations from your life, childhood homes, schools, workplaces, or strange amalgams, where your bedroom contains your office furniture and opens onto your grandmother's backyard. Geography is fluid in dreams. Spaces connect impossibly. Rooms contain other rooms that shouldn't fit. Buildings are bigger inside than outside, and all of it feels normal until you wake. You might dream about problems you're facing, though not directly. Dreams tend toward metaphor, toward symbolic representation. If you're worried about work, you might dream about being late or unprepared or lost. If you're processing a relationship difficulty, you might dream about conflict or separation, or trying to communicate, but not being heard. Your concerns will be there, but dressed in dream imagery, translated into scenarios that feel different, but carry similar emotional weight. Or you might dream about nothing obviously related to your waking life. Random memories might surface, people you haven't thought about in years, places you visited once and forgot, experiences from childhood that seemed insignificant. Your brain will pull from anywhere in your mental archives, combining elements in surprising ways, creating narratives that wouldn't occur to your waking mind. Whatever you dream will be uniquely yours. No one else will have these exact dreams. They're generated by your specific brain, with your specific memories and concerns and personality. They're as individual as your fingerprints, as personal as your thoughts. Dreams are the most private art form, created and experienced by you alone, existing nowhere but in your consciousness. You might remember some of tonight's dreams. Maybe you'll wake from one, lying in the dark with images still vivid, emotions still present. Maybe you'll wake in the morning with fragments, a scene, a feeling, a person, disconnected pieces that don't quite form coherent narrative. Maybe you'll remember nothing at all, waking without any dream recall, though you will have dreamed multiple times. Most dreams are forgotten within minutes of waking, and that is completely normal. Whether you remember or not doesn't matter to the dreams themselves. They'll serve their functions regardless. Memory consolidation, emotional processing, neural maintenance. All of it happens whether you remember dreams or not. Remembering is nice, gives you access to the experience, but it is not necessary. Dreams work in the dark, behind conscious awareness, doing their jobs without requiring your recognition. But if you do remember, treat them gently. Don't demand they mean something profound. Don't force interpretations. Just notice them, appreciate them. Let them be what they are. Some dreams will feel significant, others won't. Some will linger, others will fade immediately. All of it is part of your dream life, your nightly journey into the unconscious, your brain's creative expression while you sleep. The dreams are waiting for you now, just beyond the edge of consciousness, ready to begin once sleep deepens enough. They're patient, these dreams. They'll wait however long it takes for you to fall asleep, and then they'll begin, unfolding in their own time, following their own strange logic, showing you things you never consciously planned to imagine, taking you places you didn't know existed in your mind. The dreams are waiting, and you're almost there, almost ready to meet them, almost asleep enough for the nightly theater to begin. There is nothing left to do now, nothing to figure out, nothing to remember, nothing to achieve. The learning is complete. The exploration is over. Now there is only sleep, only rest, only the gentle release of waking consciousness and the descent into sleep's embrace. Let your body become completely heavy. Let every muscle relax fully. Let all tension drain away. Let yourself sink into whatever supports you. Mattress, couch, floor, wherever you are. Feel the weight of your body, the solidity of it, the way gravity holds you down. You don't need to hold yourself up. You don't need to maintain anything. Let yourself be held, supported, cradled by the surface beneath you. Let your breath continue at its own pace. You don't need to control it. Don't need to breathe in any particular way. Your body knows how to breathe, has been breathing since the moment you were born, will continue breathing through sleep without your awareness or management. Just let breath happen. Notice it if you want, or let your awareness drift elsewhere. Either way, breath continues, automatic and trustworthy. Let your mind become completely quiet. Thoughts might still arise, that is natural, but you don't need to follow them. Let them pass like clouds, appearing and disappearing, not hooking you into engagement. You're not thinking anymore. You're just being, just existing, just present in this liminal space between waking and sleeping. Let go of the day. Whatever happened today, it is over now. Whatever didn't happen, whatever you didn't do, whatever you should have done, none of it matters right now. The day is complete. Tomorrow hasn't arrived yet. There is only this moment, this breath, this gentle fading of consciousness. You can release everything, all concerns, all responsibilities, all plans, all worries. Release them into the dark. Let them go. Let sleep take you. Let go of yourself, the self that maintains boundaries, that monitors and judges, that worries about how you're perceived, that holds yourself together. Let that self soften, dissolve, fade. You don't need to be anyone right now. You don't need to maintain identity, maintain awareness, maintain anything. You can let the self you usually are drift away, knowing it will return in the morning, but for now, release it. This is what sleep requires: complete letting go, complete surrender, complete trust that you can release control, release consciousness, release everything, and you'll be safe. You'll be fine. Your body will continue breathing. Your heart will continue beating. Your brain will continue functioning, managing sleep stages and dream generation and all the complex processes that happen during sleep. You don't need to be consciously present for any of it. This is a nightly practice of surrender. You do this every night, though you might not think about it this way. Every time you fall asleep, you're practicing letting go, practicing trust, practicing release. You're dying a little death, losing consciousness, losing control, and trusting that you'll resurrect in the morning, consciousness returning, self-reassembling, you waking up to be you again. Sleep is approaching now. You can feel it, can't you? That gentle pull, that fading of awareness, that softening of thought. The boundary between waking and sleeping is thin, permeable, almost transparent at this point. You're hovering at the threshold, about to cross, about to release fully into sleep. Let it happen. Don't resist. Don't hold on. Just let sleep take you gently, peacefully, naturally. You're safe to sleep, safe to dream, safe to let go completely. Nothing bad will happen. You'll simply rest. Your brain will cycle through its stages. Dreams will come and go, and hours from now you'll wake, having been cared for by your own biology, having been held by sleep, having been restored by rest. Trust this process, trust sleep. Trust yourself. Fall, sleep. Release everything and allow consciousness to fade. Allow sleep to take you. Allow the night to unfold as it will. The dreams are ready. Your brain is ready. You're ready. There is nothing more to do, nothing more to think about, nothing more to be. Just sleep, just rest. Just let go completely into the peaceful darkness of sleep. This journey together is ending now. We've explored the science and mystery of dreams, traveled through neuroscience and philosophy, looked at sleep from every angle. We've learned how dreams work, why they might exist, what they contain, how they relate to memory and emotion and consciousness. We've seen dreams through the lens of different cultures, different traditions, different ways of understanding. But more than anything, we've honored dreams, recognized their value, their importance, their mystery. Acknowledge that they're part of your life, part of your experience, part of what makes you human. Dreams aren't separate from you. They're you in another mode, your consciousness configured differently, your brain expressing itself in the language of sleep. You're remarkable, you know. Your brain is capable of extraordinary things. Every night, it generates entire worlds from nothing but neural activity. It processes memories, regulates emotions, consolidates learning, maintains neural networks, solves problems, practices skills, explores possibilities. It does all of this automatically, reliably, without your conscious input. Your brain is a marvel, and dreams are one of its most beautiful expressions. Tonight, you'll experience this marvel firsthand. You'll dream multiple times, in multiple cycles, each dream different, each one unique, each one generated by your own mind. These dreams will be yours alone, private experiences that no one else will ever fully know. They might be pleasant, might be disturbing, might be neutral, might be vivid or vague or anywhere in between. Whatever they are, they'll be your dreams, expressions of your psyche, windows into your unconscious. You don't need to do anything special with these dreams. You don't need to remember them or interpret them or learn from them. They'll serve their purposes whether you consciously engage with them or not. Your brain will do its work. Memory will consolidate. Emotions will process. Neural maintenance will occur. By morning, you'll wake refreshed, not because you consciously managed sleep, but because you allowed it, because you trusted your brain to do what it does best. Sleep is a gift. Dreams are a gift. Every night your brain gives you these experiences, this restoration, this renewal. Every morning, you wake changed, subtly, imperceptibly. Yesterday's experiences have been integrated. Today's challenges will be faced with yesterday's lessons consolidated, and tomorrow's possibilities open before you, informed by all the sleep work that has happened in between. So sleep now, sleep deeply, sleep peacefully. Let this night be a good night, a restful night, a night of healing and processing and renewal. Let your dreams come freely, whatever they are, accepting them without judgment or fear or expectation. Let sleep carry you through the dark hours, holding you safely, restoring you completely, bringing you gently back to morning. May your sleep be deep when depth is needed. May your dreams be meaningful when meaning serves you. May you wake refreshed, restored, ready for another day. May you carry with you some small sense of wonder about this nightly journey, this mysterious process, this remarkable capacity you have to sleep and dream and wake renewed. Thank you for this time together, for your attention and curiosity, for your willingness to explore dreams. Thank you for honoring sleep by being here, by listening, by learning. Sleep well tonight, and every night, dream well. And when you wake, know that your brain has been taking care of you, working through the night, ensuring that sleep and dreams serve their purposes, that you emerge restored and ready. The dreams are here now. Sleep is upon you. Consciousness is fading. The threshold has been crossed. The night's journey is beginning. Let everything go. Rest completely. Sleep deeply. And dream whatever dreams your mind creates. Experience whatever your unconscious offers. Travel wherever tonight's dreams take you. You're safe. You're held. You're sleeping now, or about to sleep, or hovering in that space where waking and sleeping blur together, where you're neither fully conscious nor fully unconscious, but somewhere in between, in that liminal space where dreams begin. Good night. Sleep well. Dream beautifully, and wake tomorrow refreshed, having rested, having dreamed, having completed another night's journey through the mystery and wonder of sleep. The script ends here. The voice fades to silence, and you, wherever you are on the journey from waking to sleeping, you continue, you dream, you rest. The night holds you now. The dreams await, and everything, absolutely everything, is perfectly, completely, peacefully fine.